观众朋友、贵宾，大家好，大家早安！非常欢迎大家莅临到国家生技研究园区招商暨人才与技术媒合会。我们举办了一共4届的活动。那今年呢，我们也会持续的展现园区丰沛的生医转译能量，不仅提供进驻厂商及国内团队展演的一个舞台，也借此进一步与投资人及国内外药厂进行交流与合作链接，活络台湾生技生态圈。Good morning, ladies and gentlemen. Welcome to the National Biotechnology Research Park Investment Promotion, Talent and Technology Matchmaking Conference. This event has been held for 4 times, and this year it continues to demonstrate the park's abundant biomedical energy, not only providing a stage for resident companies and domestic teams to perform, it can also be used to further communication and cooperation with investors and pharmaceutical companies and invigorate Taiwan's bio ecosystem. Okay, so in the beginning, we are very honored to invite several distinguished guests to give us a welcome remark. 首先呢，我们非常荣幸可以邀请到几位贵宾来为我们致欢迎词。第一位我们要邀请到的就是中央研究院的廖俊智院长，请帮我们掌声欢迎他。First, we would like to invite President of Academia Sinica, Dr. James C. Liao. Welcome.
Some of you come from abroad, and after several long travel trips, it's indeed our great pleasure, and we're very happy to see so many investors, so many companies, as well as dignitaries from everywhere all get together to showcase our biotech development. You know, the NBRP, National Biotech Research Park, after about more than a decade's planning, we officially opened up this park about 7 years ago. And now the park is in full house. And thanks to all the efforts of the operating team, we now have close to 50 startup companies at various stages. So today is an opportunity for these companies to showcase their technology, and we wish that by doing this, we will be able to match the potential investors as well as the existing companies, and also use this opportunity to inspire the current researchers how to translate their fundamental research to practical applications. And speaking of that, the fundamental research is a primary goal, primary mission of Academia Sinica. But we all know that we cannot just stay in the area of basic research. To make the important impact, we will have to translate our findings in the laboratories to practical use. And this kind of venue is the perfect situation that we can learn from each other how to get our results out of our laboratory to practical use. So in the next 2 days, we'll have a series of activities. I'm sure that all the participants will have plenty of opportunities to talk to experts in this area. So I wish you a great success and full of ideas in the next 2 days. Thank you very much.
好，非常感谢廖院长的欢迎词，请回座。Thank you, President Liao. Then I would like to invite the next VIP guest to come up to the stage and give us a warm encouragement. Please welcome Chen Jianren, former Vice President of the Republic of China and Academician of Academia Sinica. 请帮我们热烈掌声欢迎中华民国前副总统陈建仁院士，掌声欢迎。
President Liao of Academia Sinica, Director Wu of Biomedical Translation Research Center, Professor Lodish, Academician Law, Deputy Minister Lin of Ministry of Health and Welfare, invited speakers, distinguished guests, ladies and gentlemen. Good morning, everyone. I would like to start by thanking the organizers for their hospitality and for hosting this event here at BioTrack and NBRP. I'm very pleased to see so many biomedical experts, heads of important organizations, and high-level representatives today. A warm welcome to you all. I'm profoundly honored to witness the convergence of brilliant minds and innovative research that epitomized Taiwan's commitment to excellence in biomedicine. Taiwan has long been recognized as a global leader in the semiconductor industry, and our commitment to advancing biomedical research remains unwavering. The Academia Sinica stands as a shining beacon of our dedication to harnessing scientific discovery for the betterment of humanity. Today, we have the privilege of showcasing the remarkable achievement and groundbreaking discoveries that has emerged from our collective efforts in Taiwan biomedical research, from pioneering therapies that holds the promise of curing disease to cutting-edge technologies that are revolutionizing healthcare. Each project presented today represents the culmination of years of dedication, collaboration, and ingenuity. I'm particularly delighted to welcome our distinguished guests, Professor Harvey Lodish and Professor Andrew W, whose expertise and insights are invaluable to our pursuit of excellence in biomedical translation. Their presence serves as a testament to the global significance of our endeavors and to the collaborative spirit that defines Taiwan's approach to scientific innovation. Furthermore, I'm also very pleased to recognize that during today's demo day, we are hosting MIT courses offering attendees the opportunity to engage with world-class experts and expand their knowledge in key areas of biomedical science. This collaboration exemplifies Taiwan's commitment to fostering international partnership and nurturing the next generation of scientific leaders. As we celebrate the achievement of today, let us also reaffirm our commitment to the future of biomedical research in Taiwan. Let us continue to invest in innovation, nurture talent, and foster an environment that encourages interdisciplinary collaboration and scientific discovery. In closing, I extend my deepest gratitude to researchers, partners, and supporters who have contributed to the success of BioTrack. Your dedication and perseverance are truly commendable, and I'm confident that together we will continue to push the boundary of what is possible in biomedicine and improve the lives of people around the world. Thank you, and may today's demonstration inspire us all to reach greater heights in the pursuit of scientific excellence and human well-being. Thank you very much. Thank you.
好，非常感谢陈前副总统的勉励跟到场支持，谢谢，请回座。Thank you, former Vice President Chen. Next, we have another VIP to bring us some encouragement. Please welcome Dr. Wu Hanzhong, Director of the Biomedical Translation Research Center at Academia Sinica. 我们这边呢，欢迎到的是中央研究院生医转移研究中心的吴汉中主任。
Greeting to President Liao, former President Chen, and Vice President Tang, or our Deputy Minister Lin, and our honorable guest, Professor Harvey Lodish, Professor Andrew W, and all of our honorable guests, and ladies and gentlemen. welcome to National Biotechnology Research Park, NBRP, Biomedical Translational Research, Biotrade, Academia Sinica, and join this 2024 NBRP Demo Day. It is my great honor to express our warmest welcome to all of our esteemed guests joining today's event, both in person and online. I would like to welcome for our four distinguished speakers from the MIT, Dr. Harvey Lodish, Dr. Angelo, Dr. Lauren Foster, and Dr. Novalia Pishesha. They will not only share their professional experience on successful translating innovative research to the clinical application and startup foundation, but they will also deliver insightful lecture in the MIT master classes that will be held following the demo day. At this time, I would like to express my gratitude to all of distinguished speakers, as well as modulator, panelists, participants in this event. I'm also deeply grateful for support of Academia Sinica, co-organizer and the main partner, and our colleague in making this event possible. NBRP is an annual event organized by Biotrade of Academia Sinica. It is in 4 years. Demo Day serves as an important platform for experts and representatives from the government, academic, and the company to network and exchange a valuable option on important topic of biotech in Taiwan. Over the year, Demo Day has facilitated talent matching, the partnering opportunity for many startups and the translational research team with pharmaceutical and biotech company, as well as the venture capital. In addition, we have an opportunity to interact with the inventor and the industry partners through the pitching, poster presentation, and the one-on-one partnering. These activities are crucial to fulfill the goal of the NBRP and to establish a robust ecosystem for biotech in Taiwan that can accelerate innovative research to product and improve human health care. This is also the vision of the Biotrade and Academia Sinica. Demo Day this year is focused on discussing the key factors that are important for translational research, technology transfer to industry, drug development, and growth biotech company. I wish all of you will have enjoyable experience and will gain deep insight in this 2 days event. I believe this event can serve as a platform for all participants, establish a meaningful collaboration. Let us all continue to innovate, inspire change, collaborate, and to promote human health and welfare. Thank you.
Thank you， 谢谢吴主任，请吴主任留步在台上哈。那我们不用在讲台那边，因为等一下我们会撤这个讲台，对，稍微在旁边一点点，对。我们等一下呢，在这个大日子也希望可以邀请到众多贵宾一起上台合影。So I would like Director Wu to remain on stage because on this big day, I would like to invite several guests to come up to the stage and take some group photos. 好，在那之前呢，我们先提醒一下后面4排座位的贵宾，因为等一下我们有个大合照，所以我们 希望最后4排不要坐人。现在呢，后面4排的人可以帮我们往前面找位置坐。好，那我们现在来邀请上台的嘉宾哦，就是刚刚呢有帮我们致辞过的。第一位邀请到的是我们廖俊智中央研究院院长 ，James C. Liao Academia Sinica President。好，接着我们邀请陈建仁，中华民国前副总统暨中央研究院院士。Chen Jianren, former Vice President of the Republic of China and Academician of Academia Sinica。接着我们欢迎唐唐，中央研究院副院长 Tang K. Tang, Academia Sinica Vice President。Please welcome Mr. Harvey Lodish, Massachusetts Institute of Technology, Professor of Biology and Biological Engineering。好，紧接下来邀请林静怡，卫生福利部政务次长。金依令 Ministry of Health and Welfare Deputy Minister。欢迎张宏仁，上腾生技顾问股份有限公司董事长暨总经理。Hong Zhen Zhang, YFY Biotech Management Corporation Chairman and CEO。接着下来欢迎 Andrew W. Low, Massachusetts Institute of Technology Charles E. and Susan T. Harris Professor。欢迎罗文全，中央研究院院士。接下来邀请到的是陈玲金，中央研究院院士 Alice Linting Yu, Academia Sinica Academician。接着欢迎彭信坤，中央研究院秘书长，辛坤 Pong, Academia Sinica Secretary General。接着邀请到的是刘义如，台湾大学财务金融学系兼任教授 Christina Y. Liu, Department of Finance, National Taiwan University Adjunct Professor。好，我们请大家可以稍微侧身一点点哦，往中间靠拢。好，接着下来继续欢迎马海怡，美国维吾资本投资公司创业合伙人 Joe Shan, Vivo Capital LLC Venture Partner。好，接着下来邀请 Lauren Foster, MIT Technology Licensing Office Associate Director。Please welcome Novalia Pishesha, Boston Children's Hospital, Harvard Medical School Assistant Professor。So welcome our distinguished guests。好，请问一下摄影师还需要再靠拢一点吗？这样子 OK 吗？好，稍等一下下，我们调整一下哦。Let us make some adjustment. All right， 好，可以了哈，可以了哈。摄影师这样拍 OK 吗 ？OK 哈，好。So let's take a group photo. Please look at our photographer waving his hand. 来，帮我挥手。All right, 3, 2, 1. 好 ，Please look to your left. 看一下你们的左手边。Look to your left. 3, 2, 1. Our distinguished guests, look to your right. 看一下右手边。3, 2, 1， 好，还有哪边要画面？挥手，中间，哦，比个赞 ，Everybody thumbs up. Another round of photo. Look in the middle. Look at our photographer. 3, 2, 1. Fantastic， 太棒了。So please remain on the stage because we need the second round of group photo。好，第二轮的合照哈，我们邀请更多嘉宾一起来参与，请让我们欢迎施修明，中央研究院生医转译研究中心执行长。舒明是 Innovation Incubation Center BioTrack Academia Sinica Research Fellow and CEO。欢迎林荣信，中央研究院生医转译研究中心副主任，钟欣林 BioTrack Academia Sinica Deputy Director。欢迎李文山，中央研究院生医转译研究中心副主任，温山李 BioTrack Academia Sinica Deputy Director。欢迎梁启明，中央研究院生医转译研究中心客座讲座，齐明良。BioTrack Academia Sinica Distinguished Visiting Chair。接着欢迎黄千月，财团法人生物技术开发中心副执行长 ，Michael Huang Development Center for Biotechnology Vice President。欢迎陈秀辉，财团法人生物技术开发中心代理执行长 ，Xu Hui Chen Development Center for Biotechnology Acting President。接着欢迎秦贤静，国家实验动物中心主任 ，Xian Jing Chin National Laboratory Animal Center National Applied Research Laboratories Director General。 接着欢迎涂醒哲，财团法人生物技术开发中心董事长 ，Shinja Two Development Center for Biotechnology Chairman。好，接着欢迎吴忠勋，台湾生物产业发展协会理事长 ，Chongxin Wu Taiwan Bioindustry Organization Chairman。好，接着欢迎吴秀梅，卫生福利部食品药物管理署署长 Shou Mei Wu Taiwan Food and Drug Administration Ministry of Health and Welfare Director General。欢迎周慧全，美国全新医药生技公司总裁兼执行长 Judy Cho Ultra Bio Inc. President and Chief Executive Officer。Please welcome Alice Chen， 美国生命科学合作伙伴加速器执行副总裁 ，Accelerator Life Science Partners Executive Vice President。好，最后我们欢迎 Yvonne Chen， 美国加州大学洛杉矶分校副教授 ，UCLA Associate Professor。好，那我们等贵宾到台上来就位，一样请摄影师引导我们。目前画面 OK 吗？会被挡住是不是？要稍微间隔站是不是？好，稍微间隔一下，这样可以吗？好，那一样先看一下我们中间大会摄影师，好，一样帮我挥手 ，Look at photographer with me in 3、3、2、1。好，看一下你们左手边 ，Look to your left，3、2、1。All right, to your right， 看一下右手边，3、2、1。好，在一起比个赞，是不是 ？Everyone thumbs up. One more round. One more round. Thumbs up. 3, 2, 1. All right, our officials, distinguished guests, thank you very much, and please be seated. So on this big day, I would like everybody have a group photo. So after you're seated, we'll have our photographer to come up to the stage and take a photo from this angle. So after everyone's ready, then we take the photo. 我们等大家就座之后，再从台上帮大家拍一个全体合照。最后4排不要坐人哈，刚刚有提醒过各位，所以最后4排的贵宾，请帮我移动脚步到前面找位置坐下哈。最后4排不要坐人，麻烦大家了。我们这样合照会看起来比较聚集比较有团结的感觉，好吗？好，今天真的是非常特别的一天哦，众星云集，大家为我们的活动增添非常多的光彩。那这里我们也有这个手拿板，让大家可以拿着。So I like our distinguished guests and officials hold the board for us for the perfect photo. 好。来，现场媒体朋友、摄影师可以帮我到台上来，我们来一个全体合照，好吗？好，我们等大家就定位。哦，我们还有一个手拿板，是不是？好，我们手拿板赶快先上完，谢谢。哇 ，Demo Day 的板子。好，今天我们齐聚在这个 NBRP Demo Day 的活动现场。好，我们先看一下我们台上摄影师 ，Everybody, 3, 2, 1. Look out, photographer, 3, 2, 1. 好，有没有想要什么动作吗？还是动态有需要吗？比个赞是不是 ？Thumbs up。好，再来一个，比个赞，帮。好。好 ，3, 2, 1， 好 ，OK， 谢谢 ，Thank you very much，Thank you。好，大家辛苦了，相信刚刚几张照片呢，一定会让大家非常满意哦。那也为今天的活动留下难忘的回忆。 那为期2天的活动呢，我们将会帮大家带来趋势论坛，还有专题演讲、投资媒合擂台，还有国际链接、1对1国际媒合会、人才媒合以及生医新创海报展等等的主题活动，期望为台湾生技生态圈增加更多的合作机会，加速产业的发展。The 2-day demo day includes 6 major themes, including keynote speech and transform, pitch competition, international partners connection, talent match, one-on-one partnering, and poster competition. We look forward to creating more opportunities for collaboration within Taiwan's biotechnology ecosystem and accelerating industrial development. So first, let's move on to keynote speech 1. We are honored to invite Professor of Biology and Biological Engineering in MIT and a founding member of the Whitehead Institute, Dr. Harvey F. Lodish, as our keynote speaker, and we'll have Academician of the Academia Sinica, Dr. Alice Lin Ting-Yu as our introducer. 好，首先呢，我们即将登场的就是专题演讲1，非常荣幸可以邀请到麻省理工学院生物学和生物工程学系的教授 Harvey F. Lodish 作为我们的主讲人。那同时呢，会请到中央研究院院士陈玲金陈院士担任引言人，请帮我们先用最热烈的掌声欢迎陈玲金院士。Please give a warm welcome to Dr. Alice Lin Ting-Yu.
Ladies and gentlemen, distinguished guests, it's my honor to introduce our speaker, Professor Harvey Lodish. As we know, he's a professor of biology and biological engineering at MIT. He's also the founding member of the Whitehead Institute for Biomedical Research. He got his bachelor degree in chemistry and PhD in genetics from Rockefeller University. And this was followed by 2 years of postdoctor at MRC, England, with 2 Nobel laureates, Sidney Brenner and Francis Crick. He was then recruited to MIT and quickly promoted to full professor in 1976 at the age of 35 years. So through this, more than 50 years of professional career, my husband, Dr. Jiang Yu, who's sitting here, and me, had the pleasure of crossing his path 3 times. The first time is in early 1970 when John discovered the protein, important protein for red cell membrane, and showed that it is an intramembranous particle. He called it BAN3. And Harvey is the one that cloned the gene for BAN3 subsequently. He went on to clone many important genes, including the transporter for free fatty acid, glucose transport, erythropoietin receptor, TGF-beta, and so forth. I cannot name them all, okay? But the point is that his academic and scientific contribution is tremendous, reflected by his election as a member of the National Academy of Science and National Academy of Medicine in USA. He also mentored more than 200 students and postdocs, including 2 that won Nobel Prize later on. One is Aaron Chichenova for discovery of ubiquitin, and the other one is James Rothman for discovery of vesicle trafficking. It's all due to his mentorship. So now I'm coming to the second opportunity to cross paths with him. in early 1980s, he formed the very first biotech company in Boston called DEMO Biotech. As it turns out, this is a company that generated the very first human mouse chimeric anti-GD2. And that's the antibody that allowed me to take it to submit IND to FDA and started phase 1 all the way to phase 3, reaching its approval by FDA in 2015. I'd like to take this opportunity to thank Harvey for doing that. He subsequently became the founder and scientific advisory for 14 more biotech companies, including Genzymes, I think, Rubiotics, right? Therapeutics. Anyway, we'll hear more about it, yeah. The last but not the least, he served as a scientific panel, advisory panel for NIH, NSF, American Cancer Society. He's also a trustee, board of trustee at Boston Children's Hospital. And when I asked him about my son, Timothy Yu, who works at the Boston Children's Hospital, he said, oh yeah, I know Tim since 2014 for his work in rare disease. So this is the third time our paths crossed again. So I'm going to stop here and let's welcome Harvey.
You know, it's very common to thank the introducer for a very kind introduction, but this was a very special introduction. And I really do appreciate it, Alice. Thank you. Am I clear in the microphone? Is it working? Good. So I'm really here to explain how the Boston biomedical biotechnology ecosystem evolved. I've been part of it since the 1980s when we started Genzyme and built some of the first products, first drugs for rare diseases. And it continues to the present day. And I will go through several topics. A brief history of biotechnology, how one builds successful companies, and then some aspects of building the biotech ecosystem in Boston. Throughout, I will stress the importance of faculty entrepreneurs, faculty members who help start and grow and nurture biotechnology companies. What I do not mean is faculty members who leave their academic positions to run companies. I have never actually run a biotech company, but I, like many, many of my colleagues at MIT and Harvard, we have served on advisory boards, boards of directors of companies. Alice mentioned my service on the Children's Hospital Board of Trustees. There, almost 20 years ago, I helped the hospital develop programs, lectures for faculty members, to explain to them how they can take research out of their laboratory, actually clinical drugs, clinical tests, a whole variety of therapeutics, either to license them or to start their own biotech companies. So again, a theme throughout will be faculty entrepreneurs. Finally, and importantly, I will talk about the role of the Massachusetts government in supporting life science industry in Massachusetts. The Massachusetts Life Sciences Center was given $1 billion over a 10-year period to spend in ways that I will describe to support biotechnology in Massachusetts. What is important is this was under the Secretariat of Economic Development, not health, not science, but economic development. And I met regularly with these Massachusetts officials to explain to them how what we were doing was enhancing biotechnology. So as you heard, I've been in biotechnology for a long time. I'll talk about Genzyme a bit later on. But I also use this slide to point out that not every company is successful. Two of my companies, and probably a third, will fail. And this is simply the world that we live in. Failure is not considered fatal. That is, one picks oneself up and starts the next company, and we keep going. And the rewards, as we'll see, are actually producing new therapeutics, diagnostics, and so forth. You've already heard about these, and I will talk about them later on. But again, the Massachusetts Life Sciences Center was under economic development. And I would suggest for Taiwan that economic development be a signature way of enhancing biotechnology, creating jobs, creating opportunities for students to take their science into the marketplace. And just to remind everyone, what we do in our research labs is not develop drugs. We do what is called proof of concept research. We may have a molecule that works well in a mouse or perhaps in a monkey, maybe even in 3 or 4 humans in a preliminary clinical trial. But that's not necessarily a drug. It requires a for-profit company to take these advances to optimize the molecule or the gene therapy. That takes a lot of teamwork to be able to manufacture it reproducibly and under good manufacturing process, to undergo the many clinical tests that are required. That costs tens of millions of dollars. This is a slide I got from Andrew Lowe, and it really illustrates, importantly, that it does take years and millions of US dollars to actually get a drug. And this cannot be accomplished in academic research institutes. It requires a for-profit company. And I now argue that we have actually obligations to take research from our laboratories into biotech companies. That is, all of us in different countries in many different ways have been supported by public financing, essentially taxpayer money in one form or another. And I argue that we now have an obligation. If any of us has done research, or some of us are the leaders in a particular field of research, that we have incurred an obligation to work with companies to make sure that the work is transferred to the public good. So a brief history of biotechnology will illustrate some of these important points. Until the 1980s, The only drugs that we had, with the exception of insulin, were small molecules made by technologies of organic chemistry that we ate by mouth. And the large pharmaceutical companies understood how to make and test these molecules. But it was from academic labs that were involved in the recombinant DNA revolution, the ability to clone a human gene and make more of it in pure form by expressing it in recombinant cells. And this led to the initial products of the biotechnology industry and some of the very early companies, a few that I list in Boston: Biogen, Repligen, Genetics Institute, Genzyme, Immunogen, and I'll talk a bit about Genzyme in my own role. The point is, this came directly out of academic labs, and each of the companies on this list were started by leading academic scientists. And the initial products of the biotechnology industry, these recombinant proteins, still are major products and major drugs. In fact, if one looks at the drugs that, in terms of the dollar value of drugs sold in the United States, pharmaceuticals, you can see in red that 10 of the top 15 drugs are recombinant proteins, many of them monoclonal antibodies that are again made by the technologies of recombinant DNA expression in cultured cells. We are all aware of the mRNA vaccine and how it had saved millions, tens of millions of lives during the COVID epidemic. What is less realized is that the Pfizer COVID drug, COVID vaccine, was the largest selling biopharmaceutical in the world in 2022. So not only did it save millions of lives, it made a great deal of money for the investors, similarly the Moderna drug. And of course, as the human genome was sequenced in Boston by Eric Lander and his many, many colleagues, we now have access to 20,000 human genes, and probably more that we still don't know about. But this has led, again, to a burgeoning industry of antisense oligonucleotide therapies, of gene therapies, both adeno-associated virus, lentiviruses. Great accomplishments recently announced. We have 2 gene therapies for sickle cell anemia, a genetic disorder that devastates much of sub-Saharan Africa. And as I point out, it only costs $2 million. There's a lot of work that needs to be done to get these down to where people can actually use them. But we have these therapies, cell therapies, increasingly gene editing. And the challenge is to take these discoveries into companies, either startup companies or licensing to established companies, so that this research can be done for the benefit of all. And that leads me to my second topic, which is building biotechnology companies. And I will stress the role of faculty entrepreneurs. One needs a number of things to make a biotech company. I think we all understand the need for protected intellectual property, a patent that can be licensed exclusively to a company, either a startup company or an established company, such that they will be willing to spend the huge amounts of money necessary to develop that proof of concept into a drug. I'll talk about the role of entrepreneurial faculty in serving on the scientific advisory boards and the boards of directors, and how they greatly facilitate the growth of these companies. One needs a business plan, and that is something scientists don't think about. I certainly don't think of business plans, but I work with people who are excellent in doing it. Biotechnology, as I like to tell my classes, is a team sport. Yes, you have leading academic scientists, but you need leading economists, people with great experience in business, law, finance, marketing, bioproduction. Actually making a milligram of a protein is not terribly difficult. Making kilograms of the protein and purifying it requires a whole separate set of talents under the aegis of chemical or biochemical engineers. So it requires people from a great deal of expertise. Generally, the CEO of a biotech company is not a scientist, and I'll describe that for Genzyme, but rather a business person who can understand the science and relate to the scientists, but also understand how to build that entity into a thriving company that actually makes and sells a drug. So we do need experienced leaders and workers, financial backing, usually by venture capital. And governments can play a crucial role in providing the infrastructure for biotechnology. But as I will argue, leave the details to the marketplace, to private investors and private funding. So intellectual property, you will hear more about from Dr. Lauren Foster. I just want to show two slides, really taken from her lectures to my class, that point out the essential role of a technology licensing office in a university, who are really the gatekeepers who decide whether someone's research idea actually could be the basis of a company or the basis of a drug, whether it should be licensed to an existing company, whether it should be licensed to a startup company. These are business decisions, not so much scientific decisions, but really business decisions. And importantly, technology licensing offices, and Lauren will stress this, are not in the business of making money for universities or research institutes, but rather, as I said, to take the research out of the laboratories and make sure it is used best for the public good. A business plan many of you will be familiar with, but many of you will not. You see, things like budgets, market size, who's going to buy your product, how much will they pay for it? Importantly, what is the competition? Are you going to be the 10th or 15th developer of a CAR T cell, or is your idea for a therapy actually novel and can really deal with a major unmet medical need? These are business decisions, not scientific decisions, but they're important in a business plan. Because again, you are going to go with this business plan to investors and convince them to give you sizable sums of money so that you can establish a company or work in a company and take these developments into the point where they can be tested in humans and used as pharmaceuticals. Education is a very important part of establishing a biotechnology ecosystem. If I start at the bottom of this slide, most of the workers in biotech companies do not have advanced degrees. Many are graduates of a college or university. Many of them are science trained. Many are in economics. But these are the people who will actually work in the laboratory, conduct the experiments under the leadership of MDs and PhDs. On top of this group is a group of highly trained MD and PhD scientists who may have actually discovered the underlying technologies and work with or advise the company as to how to take the work forward. But on top of it all, you need business people, CEOs, chief executive officers, chief scientific officers, chief medical officers, who are generally individuals with many years of experience in the biotechnology industry, who understand how to focus the company's research, how to explain to the workers in the company that our direction is not publishing papers, although many companies do publish papers, but rather develop drugs. And those are different. There are often lots of experiments people I work with in companies want to do, and I say, no, I don't really care how something works, as long as it works. You see the point? It's a whole different atmosphere. And you need highly trained people who understand this and can work with this. What is very important are the two advisory boards, the boards of directors, who are really in charge of the finances and the business development of the company. I serve on many of these boards of directors. It's good but not essential that they have a scientist who can explain to the business folk what the company is actually doing, and that's the role I play and many of my colleagues play. But the point is, this is a business board. But nonetheless, it's something that academic scientists can do and play a key role, particularly in fundraising. That is, academic scientists, many of you in the room are leading scientists who have networks of people, both scientists and business people, that you can contact to make them aware of what your company is doing. And they'll listen to you. They may not listen to the postdoc or student who's actually working in the lab, but it's an important thing that academic scientists can do, serving on the board of directors and helping raise money, and equally important, serving on the scientific advisory board. You're the leaders of the field. You know the research in this particular area better than anyone else in the world. Your job is to advise the companies, sometimes even switching directions of the research because of some new development. So the point of going through this is to stress that academics, becoming entrepreneurs, can play key roles in the development of biotechnology companies without actually leaving their academic positions. And here, let me just talk a bit about Genzyme, which will allow me to sort of bring out some of these concepts. And also, as you will see, one of my own motivations for continuing in biotechnology. So Genzyme was formed by a group of 8 scientists. And as you can see, it is an eminent group. I hate to call myself eminent, but anyway. Scientists who lead in a whole variety of fields, from cell biology to organic chemistry to enzymology, 4 of us in the National Academy of Sciences. But the key person was Henry Tremere, not a scientist, a businessman, an MBA. Henry we hired as CEO because he had the vision, not us, that one could build a company around rare disease therapeutics. He understood the marketplace. He understood what it costs to treat rare disease patients who often must be hospitalized many times during the year, and that a gene therapy or a protein replacement therapy that costs $100,000 or $200,000 a year is actually economically favorable. And he is the one that is responsible for building Genzyme to develop rare disease drugs. And the first example, the first rare disease drug, in fact, was an enzyme replacement for a lysosome storage disease called Gaucher disease, an autosomal recessive disease most common, as I will come to later, in descendants of Eastern European Jews. Generally not fatal. In severe cases, there can be brain damage and early death. But in the most common cases, it leads to an inability of macrophages, particularly macrophages, to digest a particular glycolipid, glucocerebroside. In the bone marrow, these macrophages fill up with undigested glycolipid, causing anemia, crowding out erythroid progenitors, and causing weak bones because the bones can't develop normally. Distended spleen, distended liver. Often, usually not fatal, but it could be. And we developed at Genzyme, based on earlier work at NIH, a recombinant enzyme. And we modified the carbohydrate so it would be targeted to a receptor on macrophages, taken into the cell by receptor-mediated endocytosis, and then take up residence in lysosomes, where it reverses the effects of the disease. And the therapy was based on the fact that macrophages have on their surface pattern receptors, receptors that are part of the innate immune system. In this case, a mannose receptor that binds the polymers of mannose that are typically found on the cell surface of yeast cells. Here you see a macrophage ingesting a yeast by binding the multiple mannose receptors to the yeast particle. More specifically, we made the recombinant protein with typical complex end-linked sugars, the sugars outlined in yellow, sialic acid, galactose, and acetylglucosamine. We removed these sugars using enzymes, leaving a 3-mannose core, which bound very nicely to the mannose receptor. And as you can see, the therapy works. Here's a young boy who was in one of the original clinical trials. And you could see his distended belly and other problems. You could tell he was in the drug group during the clinical test because his abdomen shrunk to a normal size. So we were very privileged at that time to develop the first therapy for a rare disease. And that's one of the reasons I'm telling you about this. This was the very beginning of biotechnology. The second is much more personal. As I mentioned, Gaucher disease is most common in descendants of Eastern European Jews. I left Genzyme around 1990 after the IPO and never thought much about the company until 2002, when our oldest daughter was pregnant. She and her husband, of Eastern European Jewish heritage, were given a battery of prenatal tests for the so-called Jewish genetic diseases, Tay-Sachs, Gaucher, many others, Joubert disease, and so forth. It transpired that both she and her husband are carriers of Gaucher, which meant that the child she was carrying had a 1 in 4 chance of having Gaucher disease. She panics, does not know that her father knows anything about Gaucher disease, but has amniocentesis and has me take the call from the genetic counselor. You know, Dr. Lodish, I'm really very sorry. The child your daughter is carrying has Gaucher disease. Now, our daughter had a very difficult decision to make about the pregnancy. I realized in a microsecond the decision was mine. I had to be completely confident from the genetics and from everything that was known about the disease. Fortunately, there was a paper that I uncovered by, just my poll, by the late Ernie Beutler, a brilliant human geneticist at the Scripps Institute, that treated 3 elderly compound heterozygotes who had essentially the same mutations as the child. And we could, and of course my daughter and her husband could, figure out that the child would be treatable with the Genzyme drug. So I'm pleased to report that Andrew is now 21. Here he is at 10 years old, getting his first infusion of the drug his grandfather helped develop. You know, he's now in university. He goes every other Saturday to the health clinic, brings some homework, sits down, they put in a line, and he gets more of the drug. He's actually a trained athlete. Here he is bicycling across the United States when he was in high school. The point is, he's never been sick a day in his life from Gaucher disease. And that is really the point. That is, we're in the business of starting companies and taking things out of our laboratories and so forth. But it's really the ability to develop drugs and treat real people that are our rewards. Genzyme, as many of you know, has continued to develop drugs for rare diseases. 3 of these autosomal recessive diseases are listed here. There are many others. The company was sold to Sanofi and continues to do pioneering research in a number of genetic diseases. So let me turn briefly to, Genzyme was a part of the initial building of the biotech ecosystem in Boston with Biogen and Genetics Institute. It was really one of the first biotech companies in Cambridge, Massachusetts. Here you see an aerial view of the current state of biotechnology. My red arrow points to the Whitehead Institute. Next door is the Broad Institute. And surrounding it are 200 or so biotech companies. I don't have an exact number because they come and go all the time. And it's about 200, more or less. And the way it works in the United States, and I believe here, is that the universities own the intellectual property. In my case, the intellectual property is owned by the Whitehead Institute. And again, the federal law encourages commercialization of federally funded discoveries, emphasizing a point I made earlier. And it generates money which can be shared with the inventors, but also staying with the university or research institute to generate increased research, products, educational opportunities, and so forth. Now, one of the reasons, yes, you should all take a picture of this. One of the reasons for success of the Cambridge biotech ecosystem is this rule, not really rule, but policy, that MIT and many other research institutes have, where faculty members can spend 1 day a week on outside consulting. We can, and I do, consult for many not-for-profits. I also consult for and sit on many boards of directors, as do most of my faculty colleagues. At the end of each year, we must account for the hours and days spent on each of these projects. But the point is, MIT, traditionally being an engineering school, has this policy to promote the transfer of research and developments into the clinic. And as you'll hear later, MIT offers many courses in entrepreneurship. One example, which I will briefly touch on, is a course that I teach with Professor Andrew W and several other colleagues called The Science and Business of Biotechnology. If anyone's interested, it's also an edX course with 33,000 students. That's a lot of students. And again, this is getting redundant, but you look at the Moderna Scientific Advisory Board, being able to make a vaccine within a year. Again, many eminent sciences. This is only about 5 years old. The Moderna Advisory Board is headed by Jacques Shostak, a winner of a Nobel Prize. Again, our top scientists are involved. This is Kendall Square, the same area that I showed you before, in 1975. It was cleared for a Nixon area space center that never happened. And the good news is we had a lot of empty space next to MIT. You can see the road running down there. That's Main Street and the Longfellow Bridge, for those of you who know Cambridge. The Whitehead Institute was the pioneer. What brought everyone together was the Human Genome Project. I show this slide. This is the opening of the Broad Institute about 15 years ago. And I show it to make a very important point for an audience. That is, it is the Broad Institute of Harvard and MIT. Standing next to Eric Lander are the two presidents of Harvard and MIT. And near the other end is the then governor of Massachusetts, Deval Patrick. And the point is, everyone is on the same page. The governor was the one who promoted the Massachusetts Life Sciences Center, that I'll come to in a moment. And to build a biotech ecosystem, it's really important that all the main players, all the universities, all the government agencies, all the government ministries work together to promote biotechnology. And fortunately, we had great political leaders in Massachusetts, Governor Patrick, who initiated this $1 billion life sciences fund that I will come to, but also brought all the parties together in what we all understand is true political leadership. Geography is very important. Here you see in red the MIT campus. I point to the Whitehead Institute where I work. This shows one of the companies that I helped start, Rubius. I started with Flagship Ventures, which was a 5-minute walk down Main Street towards the river. We positioned the company in Lab Central, an incubator that was started by the Mass Life Sciences Center, the premier incubator, I argue, in the world for developing new biotech companies. And when we got too big for Lab Central, we could move into commercial laboratories, as you can see there in 2015. Lab Central is one of the results of this Mass Life Sciences Center. It is co-working space. You walk in and you see an open laboratory. Yeah, I see the sign. You can put it down. 5 minutes. And it looks like, looks like a laboratory in almost any of your research buildings. What makes it different is that you can rent a lab bench for $5,000 a month, and that is your company. You can start the company on Friday and start research on Monday. It is actually quite competitive to get a space in Lab Central. Once you get a little bigger, you can move into a private lab that will accommodate 10 or so people, but eventually you have to leave. You can't stay in the incubator more than 2 years. Either you grow enough to survive on your own, or you close. Let me skip over this course because I'm running out of time and I'll talk about it later. Anyone who wants the syllabus, just send me an email. Just a bit about the Mass Life Sciences Center. I was privileged to work closely with the governor and the Secretary of Economics Development to literally organize the spending of close to $100 million a year. It reported to the Secretary of Economic Development. It was workforce development, creation of well-paying jobs, and development of new drugs. You see the economics going first. And that was the powerful argument that we made to the legislature, who also had to approve the funding. I don't have time to go into details. You can see it from the slides. We thought of biotechnology as very, very inclusive. Pharmaceuticals, devices, diagnostics. It was very much a bottom-up approach, taking ideas from our universities and institutes and helping these companies grow. Although it was supported by the state, we functioned completely independently. We had an independent board of directors that had on it 2 cabinet ministers, economic development and finance. But the majority of people on the board were outside, the head of the Dana-Farber Cancer Institute, co-founders of Lab Central, presidents of large pharmaceutical companies. And it was this board of directors that made the final allocation of funds. I had the privilege of bringing together the Scientific Advisory Board. You don't need to read all the names, but you can see I have many academic scientists who had extensive experience in the biotech industry, many PhDs and MDs who led scientific companies, several venture capital people. Every project, every grant that we did was reviewed both by a scientist and by a business person. And arguably, that was a major part of the success. Again, we did a lot of infrastructure, job creation, and a number of other things. And I'll just skip over all of this, but we had an accelerator program where companies could apply for $1 million loan to get them over the so-called valley of death. And they had to explain exactly what it is they were going to use the $1 million for. We wound up in any cycle only funding about 5 out of 30 companies. But we gave the companies advice from the scientists and business people who reviewed them. Many of them came back and were successful on the 2nd or 3rd try. A number of buildings that I will leave over. I will just leave you with this in the next slide, where a fair amount of our money went into education. Here, educating high school students to understand the possibility of careers in biotechnology, STEM, science and technology more generally, giving research, high-level research equipment to selected public high schools that would enable them to set up new courses that would make their students aware of what could be done in biotech. Many of them actually cloned and expressed new genes. And then finally and importantly, an internship program. Biotech was foreign to many of the college and university students 15, 20 years ago in Massachusetts. And I suspect that careers in biotech, either at science or economics or business or whatever, are not on the radar screen of many students in Taiwan. Internships in biotech companies, under 100 people, were a key part of what we did. I was told it functioned like a dating service. I've not been on a dating service, but essentially, the students would submit their CVs and description of their careers. The companies would look at them. If there's a match, the state would pay $7,000 for the summer. And over half of the students were offered and took jobs in these startup biotech companies. So we'll end where I began. That is, there's a lot that we can all do to encourage biotechnology. As I've tried to explain, faculty members can play a key role in entrepreneurs in helping start companies and serving on a whole variety of boards to encourage and help these companies grow and thrive. And then finally, government can play a key role in supporting the infrastructure for the biotech industry, supporting educational initiatives. And together, this led to a thriving biotech ecosystem in Massachusetts. And I hope next year, the year after, I will come back to Taiwan and see some of these ideas perhaps implemented and be able to tour a number of thriving biotech companies in your biotech park. So thank you.
Okay, because of the time constraint, we can take one burning question.
Well, you can come to me later and ask me anything you want.
We have break coming up. So if not, oh, okay, there's one.
Wait, hold on. I'm unbalanced. There we go.
For your accomplishment. But I just have a curiosity about how you keep your energy. Flying all around the world.
It's a passion.
Yep. Okay, let's thank Professor Lodish for the informative and inspiring talk. It's time for a break.
Thank you, Professor Lodish, and 我们谢谢陈院士。那这边呢，我们要进行中场休息时间。那等一下呢，我们会在11点10分，希望大家要准时回来。同时呢，我们会场外是备有茶点跟饮品，欢迎大家可以前往享用。对于议程有任何问题或想法，也欢迎利用中场休息时间跟讲师多多交流。So now we have a break. Refreshments and beverages are prepared for you outside the venue. And if you have any suggestions or thoughts on the current agenda, please feel free to discuss using this time and exchange ideas with the speakers. So remember to return to the venue at 11:10.
位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心进驻于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心进驻于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的 G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心供仪设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。 国家生技研究园区，加速建构我国尖端生技产业之基础及动力。除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。
gentlemen, welcome back to your event. 感谢各位贵宾回到活动现场。Next, we'll proceed on keynote lecture 2, and we are honored to have Dr. Lawrence C. Foster, the Associate Director of the MIT Technology Licensing Office, as our keynote speaker. And first, I would like to welcome our introductor, Dr. Han Chong-Woo, Director of the Biomedical Translation Research Center at Academia Sinica, to give us this introduction. 接下来呢，我们是专题演讲2。那我们这一次的主讲人呢，是邀请到麻省理工学院技术授权办公室的副总监 Lawrence C. Foster。那一样会先邀请我们的引言人是中央研究院生医转译研究中心的吴汉忠主任来为我们引言。请帮我们热烈掌声欢迎吴主任。Please join me in welcoming Dr. Han Chong-Woo.
Yeah, good morning to our esteemed speakers and all of our honorable guests. It is my great honor to introduce our distinguished speaker, Dr. Lawrence Foster from the MIT. Dr. Foster received his doctoral degree of science from Harvard University. She is a registered patent agent and associate director of Technology Licensing Office at MIT, where she has led a dedicated team focused on commercialization of innovation at MIT across the domain, including medicine, therapeutic, biotechnology, and the medical device. Before joining the MIT, Dr. Foster played a crucial role in developing business strategy and intellectual property framework for biotech company. He also contributed to strategy development of IP right for many biotech company and the university in an intellectual property law firm. With her rich experience in IP, tech transfer, management, and strategy development, we are very honored to have Dr. Foster to give us a keynote speech. So his seminar title is Transforming University Science into Impact Innovations. So without further ado, please join me to almost welcome to Dr. Foster.
Good morning, all. I'm the tall one here. Is that good? Yeah. Perfect. Well, thank you, Han Chong, and incredibly honored to be here and receive such a welcome from our hosts at NBRP and Academia Sinica. And I look forward today to sharing some information and hopefully even some inspiration about the role of universities in transforming innovations for the public good. I'm going to take one quick moment to pull up my notes here because my computer logged out. Excellent. So as noted, I have an interesting background. I like to call myself a reformed scientist. I do have my roots in scientific endeavors, but I have taken a path to explore the translation of research, and that has included a path through intellectual property protection in a law firm, as well as participating in IP development and corporate development in the private sector, in a private biotechnology company, and have now for the last 17 years been very blessed to bring my expertise to MIT and learn how to apply those for helping researchers translate their innovations. My comments today obviously reflect many years of experience at MIT in the Technology Licensing Office, but I also want to share that I have spent years learning from peer institutions as well, and technology transfer really is a community endeavor, and we share lots of knowledge and best practices. So I'd like to start, first of all, by framing technology transfer in the context of the main activities of the university, and that is the pursuit of knowledge through fundamental research. It is the training of the next generation of leaders and is impacting the real world. And as you can see from this slide, technology transfer in its purest sense can really happen in many different ways. If you think about knowledge moving, it can happen through teaching and service, graduates from the academy leaving and bringing their skills to different parts of society, dissemination of knowledge through research and publication. As Harvey alluded to, many of our faculty consult to industry. It occurs through research collaborations. And licensing and startups are one piece of this exercise, but we should not forget that there are many ways that we exchange knowledge. So the mission of the MIT Technology Licensing Office is very closely tied to MIT's mission. So MIT's mission of bringing knowledge to bear on the world's greatest challenges feeds down into the mission of the TLO. And we try to contribute to that mission by generating relationships with industry and strategically evaluating, protecting, and licensing technology. And we have actually designed a number of impact areas that reflect both the greatest challenges of our time as well as some of the biggest opportunities of our time. And this allows us to tell our story and show how we contribute to MIT's mission. So you can see as an institution, MIT has many different ways that it considers impacting the world, whether it's through healthy living and sustainability, connected world, but also advanced materials and uncharted frontiers, those things that we may not even know about today that we're looking to the future. And so the TLO identifies and tries to enhance MIT's plans in these areas. And I use this very linear projection of technology transfer to frame some of the topics that we'll be looking at today, but I do want to emphasize that technology transfer is anything but linear. You usually see some bumping around, and it is not a direct path, but we really will be thinking about the roots of innovation arising from fundamental research, how the Tech Transfer Office evaluates, considers protecting those innovations, and then working, of course, with industry to make sure that those technologies are brought to bear in the real world. So, U.S. universities receive funding from a variety of sources, and this is a snapshot of the fiscal year 23 funding environment of MIT. And what I'd like you to take away from this is the fact that about 65% of MIT's research funding still does come from the United States government, and that is not atypical. But that leaves 35% coming from other sources. And interestingly, some of the most highly represented other sources, you'll see on the top line there, about 20% of our research funding comes from the for-profit sector. So we have deep relationships with industry. And MIT's logo is mans et manus. It is mind and hand, and it really speaks to practical application of knowledge. And then we receive a fair amount of money also from foundations and nonprofits, and what I mean by these are often disease foundations. You may be familiar with Bill and Melinda Gates Foundation, Juvenile Diabetes Research Foundation. These are organizations that often have a very fundamental mission that drives their funding, and we work to hopefully address problems that impact the communities that they are representing. As Harvey mentioned, Harvey, thank you, by the way. You could give part of my talk. But as Harvey mentioned, the Bayh-Dole Act is the congressional act that not only allows United States universities to own the intellectual property that results from federal funding, but it also outlines some of our obligations. And I'm going to take a slightly different view of this than Harvey. We do have an obligation to protect intellectual property. So if the university does not choose to seek intellectual property protection on federally funded inventions, we actually give it back to the government. We have a strong incentive and obligation to commercialize the inventions, demonstrate routine reporting back to the government as to the progress of utilization of those innovations in society. And interestingly, for today's talk, there's a strong preference for United States industry and for small business as we seek our commercial partners. So this is not atypical. Many countries have a desire to promote their own economic base, and it does actually help us think about identifying and working with small business enterprises. And it also has some very interesting, what we would call obligations that we do put on our licensees. And the most interesting one, and maybe not popular one, is that products that are destined for the United States market have to be substantially manufactured in the United States. And as Harvey mentioned, one of the good incentives of government funding is it puts a requirement on us to share revenue with inventors. And people often ask, why do people do tech transfer? Why is an individual researcher motivated to do tech transfer? Receiving money is one small element of their motivation, but I hope to convince you that there is something far more profound at work and that helps them achieve a different level of satisfaction. When we work with these non-United States government sponsors, there's a different set of obligations. And so what is common here is that most funders want to see some practical application of the research that they funded. And so for non-government sponsors that are industrial, we certainly have to report to them about intellectual property that is generated, and very frequently they have the first right to license those inventions from the university, and they are a very good source and a very motivated source of licensing. These licenses are sometimes exclusive or non-exclusive, and we'll talk a little bit about that later. But the research is actually informed by the company's desire to make progress in a certain area. So these are often exercises that have a strong tie to the business of the company. As I noted as well, foundation funding has often very profound mission-centric obligations. So when we license those inventions, we have to include obligations to address certain markets, and we will gladly share money back with those. These are nonprofit foundations, and it is a source of evergreen funding. So if we are all lucky and something actually gets to market and the university creates revenue, well, then we will share a portion of that with them so that they can continue their role in funding new efforts. And this is really the virtuous cycle of tech transfer. If money is received by the university, we put it right back into MIT. With the exception of inventors who get a share for their own personal benefit, the vast majority of the licensing revenue goes right back into MIT. It is a very important source of non-discretionary funding. So universities deal with a lot of different types of intellectual property. So I'd just like to frame that for our discussion today, as MIT and our peers, we receive notices of invention that relate to patentable inventions, but this is not to discount that we also deal in copyright software, and we also deal in tangible research property. And given our business, so to speak, in teaching and research and publication, we do not typically deal with trade secrets. So our three main types of intellectual property, I talk mostly about patents, but do know that we have efforts to make sure that other types of inventions find their way to the market as well. So when we get an invention to evaluate, I'd like to, there's a lot of words on this slide, but I'd like to point out, and it is structured here intentionally in this order. So we first have to decide, do we even own the intellectual property, which is an interesting question, but MIT sits in the center of a very complex environment, as Harvey showed on his map. We often have joint ownership with other institutions, and we have sponsorship obligations. So that just frames generally what we do next. That's considered largely administrative. But second, one of the most fundamental discussions that we have early on is with the inventors. So we need to understand their perspectives. What plans do they have for the technology? What is their motivation for disclosing to the Tech Transfer Office, and why do they want to see it developed? And as Harvey tells a story of almost like an accidental personal relationship to technology, we find that many of our inventors, there is a very, very personal reason why they are studying a particular problem, and they are very motivated to bring solutions to bear on a problem that is important to them. And I give a really interesting example of Professor Hugh Hare at MIT's Media Lab. And due to an accident, he is actually a double amputee, and he has spent an enormous part of his research effort at MIT developing prosthetics, neural interfaces, and solutions, because he, as a real live individual, knows the limitations of solutions that were available to him. So these stories are actually quite common, and it reflects for the Tech Transfer Office the importance of the inventors in our process. We certainly also undertake decisions about whether or not to pursue intellectual property. If it is eligible for patent protection, we certainly look at things like patentability. We look about whether it is possible to detect infringers by the presence of sort of a trace in the final product. But equally important, we ask ourselves, is a patent the right way to maximize access to the technology? So a patent is, in fact, a limited term monopoly, as you all know. And so we are balancing in every invention. We look at whether filing a patent will provide the incentive for further development that you've heard from Harvey, the long timelines for research and development. Often a patent, an exclusive patent license, provides the incentive for that company to invest those resources so they can protect the market at the end. But there is also some fields where filing a patent may not meet our goals for allowing the fields to move forward. And there are parts of basic research, research tools and the like, where we decline to file patents, and we basically put knowledge forward consistent with the mission of the university. And then, as I just noted, for research tools and software, we use all sorts of other distribution methods. We put things in repositories so that scientists can access them easily, and we make a lot of software available as open source, again, for broad use to grow the fields. And lastly, at the Technology Licensing Office, we immediately start thinking about science as a product. So we move away from the science, and we start looking at the attributes that it may have as a product to solve a commercial problem. So we start analyzing the problem-solution approach. How does it compare? What problem is it solving? Do we even know? Sometimes we don't. How does it compare to other solutions that are available? And how does it distinguish itself? Does the market see a problem that needs to be met or no? And can the cost of the technology be borne by the market? Because some solutions may not meet that criteria. They may be very elegant, but they may be cost prohibitive. So we are really looking immediately to how to move this technology out of the university. It is science that it's on its way to becoming a product. All right. So as Harvey alluded to, the transitions from the university technology to the market, this says it may have challenges. It always has challenges. I'll make that as an affirmative statement. And we rely on our licensees to fill this gap between, as Harvey said, universities invent technology, we don't develop it. So depending on the technology, we move forward to a certain level on this linear representation across the top, from discovery to basic research. We sort of maybe tip a little bit into applied research, but then we certainly rely on the industrial sector to bring forward the technology, to integrate it with the solutions that are needed to bring it to market, to look at volume scale manufacturing, access the supply chain, understand the regulatory processes that are required to bring it to market. And this requires an enormous amount of capital and resources and talent. So what does the MIT Technology Licensing Office look for in a licensee? Well, we look for organizations that have the resources and expertise to bring these technologies forward with those product development attributes that we just talked about. So not necessarily in any particular, the size does not correlate with importance here, but it is really critical that these companies have the talent. It is not only technical. We need the business acumen. We need people with experience of navigating product development, and people who are realistic, that they understand how to proceed, when to give up if it's not working, when to pivot. And the resources that they need include not only capital, but as I've alluded to, production and capacity and supply chain, access to usually a lot of other intellectual property, and they need to understand how to navigate the market and help articulate how the proposed solution addresses a market need. And importantly, they need a business plan or a business model that is viable. And so the Tech Transfer Office in universities are really part of a journey of relationships. This is a community that undertakes this effort. It's not just the university. And our licensing staff works closely with inventors, with entrepreneurs, with venture capitalists, with startups, with corporate partners to see the transition of technologies out of the university. And as our former tech transfer director, Lita Nelson, who I know Harvey knows very well, one of her favorite mottos that I took on was tech transfer is a contact sport. So it is, you have to bump into people physically, but it is also who you know. And so this is the community effort in bringing technology forward. So as you're aware, universities license to both startups and established companies. And there are some distinct benefits and disadvantages to both, but in our experience, we have found that startups are often a good fit when there is a technology platform that has a number of different applications. When the inventors themselves support transition to a startup, again, focusing on the role of the inventor as know-how, really, it's up there. Patent is a piece of paper. The inventor knows how to make it work. These small organizations are very flexible. They have enormous, typically enormous commitment and focus, and are often more tolerant of the risks with early stage technology. That having been said, established companies are also really important players here. We often will license directly to established companies when the technology in question is an improvement to a product or service that they are already developing, or that fills a very specific strategic need that they have identified. And they certainly have an entirely different set of capabilities, including deep product development experience, access to capacity, supply chain, customers, et cetera. So this is data from 10 years of licensing at MIT. And I always like to use real data to dispel some myths and perpetuate reality. There's no fake news in this talk. So of our exclusive licenses in the last 10 years, 68% went to startups. That's a big number. And then if you factor in small businesses, which are probably the startups of about 2 years ago, you're looking at easily 3/4 of our licensing, exclusive licensing, is done to small businesses and startups. And on the flip side, non-exclusive licensing, which is typically a freedom to operate type of license, is most commonly given to large companies that may not feel the need for exclusivity. They may have other intellectual property that they can rely on for market protection. But this is not an all or nothing. So what we see in our environment very often is that technology first goes to a startup. The startup addresses some of those early product development challenges that we talked about, and then they partner with larger companies. So it's really a transformation along the way. And in the startup arena, I do want to point out that there is often a need for a period of time to let these nascent companies develop an appropriate business plan, to raise capital, to hire a management team. As Harvey said, these are you're transitioning from scientists to business people. And so we have a very robust option practice, and an option practice is basically a license that is for non-commercial purposes. It allows the company to validate and evaluate our technology, and then put together the business plan, the team, with comfort knowing that they will have the first right to negotiate a license with the university. And interestingly, it also provides MIT with access to improvements to the technology that are developed by the optionee. So we are also looking out for our own interests at some level. Because they're not yet a licensee, they may never take a license to the technology if they can't make their business plan work. So if that is the case, we will get access to their intellectual property to give ourselves freedom to operate, to license our own technology. So I would say the vast majority, this is a very low-cost agreement, costs $3,000 US, and it is really a tool that we use to help promote small teams and entrepreneurship. So MIT's licensing approach is entirely mission-driven and not revenue-driven. You're going to hear this probably from a number of people during the next couple of days, But this is a really important point, which I'm going to sort of demonstrate later. Our primary objective is to transfer the technology and achieve commercial reality for our inventions. If the licensee is successful, we certainly share in their success, but we also want to see translation first. We leverage our intellectual property. We have very, we like to think, fair and flexible licensing structures. Our goal is to maximize the number of technologies being developed. So if you think about a sporting event, we like to take many shots on goal, because you can't win a game without taking a shot. So instead of trying to pick winners, we try to put as many things out and see if they gain traction. And we are also very motivated to encourage long-standing and broad relationships between MIT and our research partners, industry, and the startup community. Very high level, we don't actually use, per se, a licensing template. We do have some common ingredients to all of our licenses, but importantly, we tailor the terms to fit the technology and the licensee's business plan. And there's been some interesting questions over the years. Should universities try to standardize their approach? And we hear actually from the startup community that they like to have a voice. They like to be able to tell us if they need something different. And so it's, in our experience, this is not a one-size-fits-all, but really a custom experience where we work closely with the licensee to design a deal. These are back-end loaded. They are, as I said, we get the vast majority of our value when the company creates value. We have obligations that the company diligently develop our technology. And we also include a lot of flexibility, and we find ourselves very frequently renegotiating licenses in order to account for changes in the company's business plan. And that is a perfectly natural evolution of technology, and we see that as just very fundamental to what we do. We do take equity in MIT startups. An MIT startup in our parlance is a company that is founded on MIT technology. So their goal, that is the founding technology of the business effort. And we find that licenses, sorry, I'm going to go backwards because you don't get to see that yet. But licensees, and the license is the beginning of a relationship. That is day one, right? The legal contract gets put in a drawer, and then you start the real work. And that is something when we think about relationships and contact sport and deep interactions and community effort, that is how we feel. So let's look at some data. Now this is the fun slide. I'm going to show you some data to understand the technology commercialization life cycle and set some expectations. So I'm going to flip through all of these to give you some data. So this is data generated from the Association of University Technology Managers. It's about 150 to 200 universities surveyed over a period of a little over 30 years. So if you look in aggregate numbers, about $1.5 trillion in research funding into universities led to about 550,000 invention disclosures, which led to about 310,000 patent applications, about 140 issued patents. This all looks great, but you can see that there's a very steep price per disclosure, about $2.6 million per invention disclosure. And at each step, there's attrition. And then on the commercialization front, what came out of this effort? About 168,000 license and option agreements, about 18,000 startups, and as of fiscal year 22 data, about 200 new drugs. So that sounds great, actually. I think that this is really an impressive slide. So then you're going to ask me, well, what comes next? So what does the university see for this? This is licensing income. So now the input is all of those commercial agreements. And what is the aggregate transfer back to the university community is about $58 billion. So I hope this convinces you that revenue generation is not the primary goal of technology transfer. For every dollar of research funding, there is a 4 cents return to the university. And then you say, well, what's wrong with you people? Like, why do you do this? You know, this doesn't seem to make sense. Well, it does if you're a university, because our goal is not to make money. Our goal is to forward knowledge, it's to have impact. And what is not shown on this slide is, first of all, we typically get a very small royalty, on average about 2%. So if we're getting $58 billion back, that means the companies are generating about $3 trillion of revenue. They are creating jobs. There are products and services on the market. There's economic development. There's taxes paid to states and governments. And it furthers a cycle of more innovation. And that is the message that I hope to leave with you today, that this is an effort that is so mission-driven, and I know it's common to think about economic return, but it will be very disappointing if that is your primary focus. So the impacts of technology transfer that should be talked about and celebrated are converting inventions to solutions for society. In the US, it's important for us to demonstrate to the government that we have commercially available solutions. We have support of local economy and beyond, and job creation and economic development. And within the academy, as I said, we are encouraging industry collaborations. We're supporting entrepreneurship and training of future business leaders. We're attracting faculty. I will say faculty recruiting, they very often come to visit the tech transfer to see how we will help them. And then again, if we are lucky enough to make money, it is shared right back into the university. So, why do we do it? As you've seen from Harvey, you'll hear from me, the process of innovation and the travel of research from disclosure and filing of patents within the academy to a funded company that makes it all the way to the market is an extremely long and time and extremely resource-intensive exercise. And the valley of death that we often seen as this dip is really something that we have to think about as a community effort. How do we help overcome these challenges? I'm going to skip over this next slide for 1 minute and go quickly to our colleagues at the MIT Sloan School who have helped us think about what are the stakeholders in the innovation ecosystem that help us traverse this valley of death. And we have not only a single university in the Boston area, we have multiple universities, including MIT. We have the entrepreneurs who are willing to take a risk and lead these companies. We have at-risk capital, and we obviously have government support and corporate support. So Harvey used his version of this. I have my own version, which does not have quite as many arrows on it, but it really is important. This is a very busy slide, but please take away that we have all of the aspects of the ecosystem surrounding MIT. So in this case, MIT is really the sort of orange color. But you will see government, you will see incubators, you will see companies, and this is a slide that represents not only biotech, but it's energy. So you see enormous amounts of industry. You see venture capital. And it is these clusters of innovation that provide those connections and support. So I'm going to go backwards now for 1 second and show you some of the time pressures that we're under. So we've said all these exercises take a really long time. But we also have data that shows in MIT's experience that if a technology is not licensed within about 5 or 6 years from the time it is disclosed to the TLO, that it's the likelihood of it ever getting licensed diminishes quite rapidly. So this is data from MIT technologies that are licensed, and at any given point, about 40% of our patents are licensed. So 89% of licenses and transfer to industry occur in the first 5 years, and then you can see this significant drop-off. So what does that mean? It just means that this is a long game. We license early, and then we let the ecosystem take hold, and then the technology matures. And although this is not life sciences, I like to use this example of commercialization of the high-definition television portfolio at MIT as a really interesting example. And you'll see here we have the revenue is on the y-axis, time is on the x-axis. We have some inflection points here. But very interesting is, if you look in 1995, is the establishment of high-definition television standards. So some of us may not even remember when high-definition television wasn't there, but it wasn't there. So what's interesting about this, if you think about it, is that the first invention disclosed to MIT was years before the market was really there. The television standard came after that. So universities are often in a position to have to put capital at risk to support patents for markets that may be emerging or we may not know what they are yet. And this is a numbers game. And so you can see here that if you first invention disclosure came to the licensing office in 1989, we had some early patent filings and issuances in the first 4 years. We filed the last patent in this portfolio about 5 years out. But if you look at the revenue line, it really starts to pick up around 2005. So this was a technology that was non-exclusively licensed because it was appreciated that it would be best positions that many players would have access to it. Think about all the electronics companies. And so we went almost 20 years before any significant revenue. You see a big blip right before the first patent expired. This actually had to do with we enforced these patents to bring some players to the market. So that's why there's a very steep increase. And then, as you can see, about 30 years out, the last patent expired and our revenue decreased with it. So this is not an atypical time frame, and as folks here who are in the life sciences can appreciate, given the long timelines of drug development and regulatory approval, it is actually quite common that the university patents that underlie drugs expire before the drug gets to market. Okay? So we found a company, we create jobs, maybe we take a little bit of equity and we get some benefit from that. But very often, the economic return is quite limited. So what do we take credit for? Let's look over some of these. These are all products and companies that are made possible through university tech transfer. This is not limited to MIT. So you can see the contributions of university research to products that reach all aspects of our lives. We have research tools, which is that cute little mouse on the bottom. We have lots of different pharmaceuticals. Most exciting, we have our new CRISPR therapy just approved by for Vertex. We have we have agricultural products, we have prosthetics, we have things that appear in our daily life, batteries, we have energy companies, we have imaging and display technology. This is what we call technology transfer. It's these products and these solutions which are the benefit. And here are some, this is a select number of startups and companies licensing MIT IP, and a similar demographic. You can see we have a really interesting play in the life sciences, and not surprisingly, but our research base also supports wonderful solutions in energy, in sustainability, in security, in batteries. And this is why we do it. This is why we celebrate it. And the success factors that allow us to thrive are varied, but I'd like to highlight a few of them. First of all, we have quality technology from researchers acting at the forefront of their fields. We have an enormous amount of external engagement that I've referred to before. So our researchers have an understanding of industry perspectives and real-world problems. We have enthusiastic and cooperative inventors, and a little bit now, not just a plug for my office, but tech transfer is a really important profession, and it is a profession. And we have experienced tech transfer professionals that come to us with a diversity of professional experience in both science, product development, and business development. And they also possess some characteristics that are really important. They're curious. They're motivated to help the inventors. They are motivated to forward MIT's mission to have technology see impact. And they are problem solvers. We are encouraged to be as flexible as we can to make deals work. We are storytellers and communicators to spread our mission. And most importantly, we are relationship builders. We build relationships all along this journey, and it is in fact one of the key goals of our team every year in measuring the success of our team is our outreach into the community and building relationships. We also blessed with very strong institutional support for the Tech Transfer Office. We have a healthy budget that allows us to put at-risk capital into patent filings that may not yet be supported by a licensee. MIT spends over $20 million a year on building its patent portfolio. And at any given time, about 40 to 50% of that is being reimbursed. So like a good investor, we have a portfolio, and we keep feeding it and trying to build a pipeline of opportunities. Harvey alluded to this, but I do think it can't be understated that we have an efficient tech transfer process with clear policies. What we can do, what we can't do, how we engage with inventors, conflict of interest, et cetera. Those are all very clear, not only to us, but to our community, so it does help the process move forward cleanly. And then, of course, the entrepreneurial ecosystem. This is not just players with resources and expertise, but it has role models for founders. We have talent in the form of entrepreneurs and investors that are experienced with early stage technology. They're experienced in working with academics. And there is a strong network and infrastructure that these small companies that go out into the ecosystem can find lab space. They can find attorneys that work with them at reduced cost. They can find all that support that these nascent companies need as they begin their journey. And although we don't like to focus on numbers, I'll end with just some metrics from our fiscal year 23. So interestingly, our starting point is typically over 600 reports. It's usually between 600 and 700 reports of invention to the TLO. We file about half of those. We certainly measure how many patents we file and issue and how much money we make. You can see our startup activity. About, I would say, a little over half is in the physical sciences and hardware. We have also a strong presence in the software space. And then we see collectively between devices, diagnostics, research tools, and therapeutics about another 40%. What is not here, and I would argue is probably one of the most important success metrics that is not measurable in any meaningful way by numbers, is faculty satisfaction and inventor satisfaction. And it is what keeps them as customers to our office and as customers in this and participants in this process. And I'll leave you with that, because I know that we all have metrics to meet, but do think about customer satisfaction. Thank you. Happy to take questions. And I did get on time. Sorry if I went very fast. I'm more than welcome to take questions.
Okay, thank you so much. Dr. First gave such a kind of wonderful talk. Yeah, it's very informative and very useful for us. So because time is limited, we allow one question. The other we will later on. Wow, so many hands. Okay, so later on we will can discuss in the lunch. Okay, so any Judy first. Yeah.
Lauren, thank you for the great overview. I mean, in the interest of time, I'll probably just ask for myself as well as for the audience. Can you comment a little bit more, emphasize on the life science? Is there anything unique compared, because MIT has a lot of great technologies, and compared to other technologies, what do you emphasize more in the life science area?
It's a great question, and on the backdrop of a university that does not have a medical school or an affiliated hospital, what I'd like to emphasize is many of our successes in life sciences stem from a deep connection and collaboration between MIT and our area medical centers, where you bring together engineers and clinicians in this concept of convergence to solve problems. Tech transfer, as you know, is quite common in the life sciences. It is perceived as a potential for enormous economic potential. So do we emphasize anything particularly different? Not really. Our approach is very equal, and we don't favor life sciences inventions because of their economic potential. We continue to work and try to see if these products will find their way to public benefit. But I will also note that pure drug inventions are very rare at MIT. So we are often looking at enabling technologies like drug delivery, a lot of device work, imaging, diagnostics. It is less common to see small molecule development. And when we work in teams, we involve the Whitehead, the Broad, Harvard. You see groups of people that bring this collaboration is more frequently what gives rise to drug inventions at MIT.
So is that fair to say for technology, tech or high-tech area, it's easier to see that linear translation into the product? But for life science, it's less measured that way from MIT particularly.
I would say no, because even in the technology arts, there are very difficult business models that are not well established. So if you think even about climate change, which is an energy, which is an area of great interest for MIT, there are business models that need to be developed and very long timelines for uptake. There are probably regulations that we don't even know about yet. So yes, there are certain types of technology that the development cycle moves quickly, and it might be more straightforward. But I don't think that there is a generalization there. Because life sciences, albeit long in a highly regulated industry, is also well understood, and it has that benefit.
Thank you so much.
I also have received 2 urgent questions, so we were allowed 2 urgent questions. Okay. Yeah, one is from Dazi, second is from Sherry. Dazi, please. Yeah. Yes.
I really appreciate your nice talk. I have served as a patent office director in National Tsinghua University 15 years ago. So I think what I feel most impressed is TLO over here in MIT has the power to renegotiate the contract to help solving the problems between licensees and the licensors. And also, I think you only own 2% of royalty from the company. It's pretty good. However, MIT is a private university. Here, Tsinghua University is a public university. So if Tsinghua owns 2%, that means government owns the equity. So sometimes will be more complicated for further development and negotiation. So I think it's a major difference between Taiwan and the US. And any solution in a wise way?
I agree with you. I mean, we do not share economic benefit back to the government, literally. And eventually it comes back. We do. We pay taxes. I pay taxes. But also, I think you've brought up a great point, which is there are differences between private institutions and public institutions, even in the United States, and they're under very different constraints, for sure.
Thank you.
Hi, thank you very much for a great presentation. My question is that you have close to 4,000 patents active, I think 3A44 currently. Maintaining patents could be very expensive, and 89% of patents are licensed out in 5 years. So could you share what's your decision-making process in terms of dropping the patent or continue paying the maintenance fee?
Absolutely. It's a great question that everybody asks, and there's not a great answer, but I will say I'll make a couple of observations. One is we do not cut early. So we tend to make a rather strategic decision whether or not to file. And if we do, we try to stick to that decision until there are data points that tell us we shouldn't. And that can come in the form of the patent office. We're having challenges getting patents issued. But if patent prosecution is proceeding and the claims are sort of in line with what is expected, at least in the United States, we will carry those patents to issuance. And in our system, you pay maintenance fees at 3 years and 7 years and 11 years. We do not trim until 7 and 11 years. So you're weighing against patent life. I will say we are very thoughtful about pursuing patent protection outside of the US because of the cost. And so if you look at any given point, our overall patent reimbursement is high. It's about 50%. For international to us, outside the US patents, their reimbursement rate is over 80%, which means we are typically only filing if there is a commercial partner engaged. That having been said, we do look at the long game. And in an area like life sciences, we do have a different flexibility, knowing that it is an industry that relies on patent protection, that we will often, if we think that the technology has legs and has a good potential, we will file in a small number of jurisdictions outside the US. Europe typically, Japan, US still make up about 75% of the pharmaceutical market, but we do make educated choices.
Yes, like Taiwan government support many research institutes. I was in a committee and we were electing whether we should drop the patent after 7 years after issuing, or 10 years, or 13 years. What would you think?
Well, I think it's somewhat of an artificial determination, because if your patent issued very quickly, at 7 years, you still may have 10 years of patent life, which is a long time to further find a licensee and further development. If you have struggled to have get patent protection and it issues after 7 years, you're always, that 7-year decision, you're saying, well, there's only, at that point, there's only 5 or 6 years of patent life left. What's the chances that this patent will have value in protecting a market? Because that's the value of the patent, is it has to protect a market that our licensee sees. So especially in the life sciences, if you license late in the game, the patents will not be in existence when the drug hits the market. But there are other values to patents, and there is we call it marquee value. There is a value to holding a patent license from an institution, a preeminent institution that helps them raise money. They are good corporate citizens, and they access our IP and try to help us promote tech transfer. But the value, to your question, the value of it as an economic driver goes down pretty quickly over time. And like everybody, we have some economic pressures as well, and we want to free up new resources to get the next generation of patents. So it's a hard game. You notice I'm not really answering the question, but.
Okay, I think this section will end here. And the last, thank you, Dr. Forst again.
Sure. Thank you, Dr. Lauren, for sharing. Thank you so much. And I would also like to thank our introductor, Director Wu. Thank you. 好，我们请两位可以回座. Thank you. And it's a lunch break, so please proceed to the registration counter on the 3rd floor dining room to collect your lunch boxes. And VIP guests, if you're one of the VIP guests, please head to room C123 for your meal. If you're unsure of the exact location of your lunch, please ask any staff nearby. 好，接下来是中午用餐时间，那请各位可以移动脚步到3楼的西餐厅领取餐盒。有佩戴贵宾证的朋友可以到会议室 C123， 会议室 C123 来用餐。那如果有人不清楚自己用餐的位置的话，也可以询问身边的工作人员。In addition to the main venue, the Biomedical poster exhibition is also set up in the west lobby on the 1st floor. This exhibition showcases technological demonstrations, product advantages, and future business plans, aiming to foster new collaboration. The afternoon sessions will begin at 2 in the afternoon. Please remember to return to the venue. Thank you. 好，除了主会场之外呢，我们在1楼西侧大厅也有生医成果海报展，会展现技术的呈现以及有产品优势、未来营运规划，期望再创合作新高峰。下午的议程会在2点钟准时开始，请各位交流之余不要忘记2点准时回来到现场，谢谢。
位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成将扩大群聚效。位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，
自己推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心进驻于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心进驻于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心共宜设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式，及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。国家生技研究园区加速建构我国尖端生技产业之基础及动力，除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。 位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心建筑于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心建筑于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心供仪设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式，及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。 国家生技研究园区，加速建构我国尖端生技产业之基础及动力。除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。 位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心进驻于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心进驻于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的 G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心共宜设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式，及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运。主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。 国家生技研究园区，加速建构我国尖端生技产业之基础及动力。除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。 位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心建筑于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心建筑于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心供仪设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式，及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。 国家生技研究园区，加速建构我国尖端生技产业之基础及动力。除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。 位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴，并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心进驻于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心进驻于园区的1栋，专精新药临床前开发与转译加值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的 G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心供仪设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。 国家生技研究园区，加速建构我国尖端生技产业之基础及动力。除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。
Returning to the event， 欢迎各位贵宾回到现场。那接下来呢，我们要继续下一个议程是趋势论坛1。So next we'll proceed on Transform 1, and we are honored to have Dr. 张宏仁, the Chairman and CEO of the YFY Biotech Management Corporation, as our moderator. And first, let's welcome our introductor, Dr. 李文山, Deputy Director of Biomedical Translation Research Center at Academia Sinica. 好，我们这边呢要邀请到的是上腾生技顾问股份有限公司董事长暨总经理张宏仁会担任主持人，然后呢，我们的李副主任会担任我们的引言人。好。Now, please join me with welcoming Dr. 李文山 with a round of applause. 帮我们热烈掌声欢迎。
Okay, welcome everyone. Come to the demo day. Okay, for the Transform 1, the key element to accelerate the drug development and enhance its success rate for biotech industry in Taiwan. And first thing I want to not introduce this section, the chairperson. 张宏仁 welcome.
So let's invite all our panelists. Join me on board. Yeah, please, everybody. Okay.
So we
okay.
like to
while my panelists are moving, I welcome you this afternoon. Okay. One thing. Okay, I believe most, if not all of you were here this morning. One thing Laura taught us about this biotechnology development is that it's not about making money. It's about humankind. Yes, and Harvey told us that it is our obligation as a researcher to license out your technology so that it could someday becoming a product to save lives. And the life you save could be your grandchildren. Okay. So I'm going to introduce, but first of all, when I introduce somebody, he will be the one to give his view on this very difficult question that we asked today: how to promote and accelerate the biotech. Let me see. There's a drug development and enhance its success rate in Taiwan. Okay, and first of all, I'd like to invite Dr. Hong Mingqi. I told you. Yes, and Dr. Hong Mingqi, the reason I invite Dr. Hong Mingqi first, because he is now the president of Taiwan's China Medical, okay? China belongs to Taiwan, okay? China is Taiwan 的中国医药大学 the president, and he also, has a very extensive experience from Texas MD Anderson Cancer Center. Everybody knows that it's a very prestigious oncology center in the world. So he had experience from both sides. That's one thing. The second thing is, personally, I think Zhongyi, the China Medical University, is very successful in trying to promote, licensing out their know-how and technology to form startup companies, and many of that has entered the capital market. So this is the reason I want to hear how they do it and how his insight for this big question we are asking this afternoon. Dr. Hong, please.
Okay, I think if you like to embarrass your friend, this is the best opportunity. That you said, you guys are so good, but then the person who sat next to me was my professor when I was a postdoc fellow in MIT. So I'm very embarrassed, okay? So I assume that today we'll talk about the drug development in Taiwan. And I remember you actually assigned job to us. You said, what we should learn Taiwan as a small island that from US. Okay. Well, first I had to agree that Taiwan is a small island. Our population is less than 10% of the US. And our territory is a little bit bigger than Massachusetts, I'm sorry, okay? But it was 1/4 of New York State. Thinking about that Taiwan's biotechnology, that how we can learn from US, I think the most important thing is to learn, right? So we have a lot of things to learn. For example, US FDA, anybody know when the US FDA was established? Taiwan is 2010, US was 1906, 100 years ago. So we are way 100 years behind. And however, having said that, should Taiwan's biotechnology 100 years behind the US? Where's the answer? Yes or no? Hey, that's what they say. Okay, I didn't say it. Okay, okay. Well, thinking about it. So now, US has 100 years or probably even longer history from us. Then what we need to learn from them is look their success. For example, first one I want to mention, clustering. That just using MIT as an example. Kendall Square, where you guys come from? Kendall Square is probably as big as Nangang. But how many companies was there? 300. Okay, 300. So cluster is important, but having said that Taiwan's clustering is moving ahead. I don't want to depress that all of us say, hey, we are all far behind. Well, look at Nangang, the Academia Sinica, actually this park. This is one of the clusters because Academia Sinica has a very strong research here. And entire Taiwan, not only Nangang, Taipei area, Hsinchu, or even Taichung and Tainan, we all have a technology park. I think Taiwan is relatively small. If we could make Taiwan all over, have this clustering, Taiwan in the future could become a biotech island. Hey, 鼓掌啦. Well, is that what we're trying to say here? And you may have said, well, that's impossible. Hey, my friend, I'm sorry. I went to US 1978. I didn't know what is a Taijidian, what is a Taiwan semiconductor company. I didn't know. Because that company was formed after I went to US for 9 years. Now, when I come back to Taiwan, I'm sorry, we're the #1. So what's wrong with that? So Taiwan's biotechnology just needs something like that. So I think the first thing, the cluster, Taiwan is already doing that. Are we extremely successful yet? Of course, not yet, because compared to US, we are far behind, but at least we started. At least now we have Taiwan FDA. The other thing I would like to say, I heard this morning you say that you guys discussed, say, universities are not supposed to make money. I raise my hand to support that, okay? So I think Taiwan needs to develop biotechnology. But the Taiwan's academic people, i.e. those people who are doing the basic research in the lab or in Academia Sinica, should actively, proactively to interact with the people working in industry. In particular, Taiwan is really small. If we think about those big pharmaceutical companies, you want to talk about Novartis, you want to talk about Eli Lilly or whatever big company. Those big companies in the US, their R&D is huge. How huge? You just go to Google to check it. So Taiwan's biotechnology, we consider we are relatively successful. But I doubt that any Taiwan's biotechnology company, their R&D is as big as US. So we need to take advantage of that academic people, how the academic people interact with the collaborate with the industry. And this has also been done in US, but US is so huge and they have experience and it's already very successful. I just use one of my professors' example. I mean, I don't know whether you mentioned this morning in Genzyme. Oh yeah. Yeah, okay, Genzyme, so you know that. Genzyme, well, I still remember that, what, 20 billion? 20 billion, it's not Taiwan billion, okay, US 20 billion. And it was only a few years, okay? And he was a founder. He was a founder. So I think we need to learn from US that because we are not so big, if our biotech company in the future as big as Taijidian, then that might be slightly different. At this moment, academic people collaborate with industry people is a must, M-U-S-T in Taiwan. That's how I feel, okay? And then I think the other thing we should learn is international collaboration. Hey, my friend, our biotechnology, what we need to learn is too many things. We virtually, everything we need to learn. Market, how to increase the value, and regulatory. There are a whole bunch of stuff we need to learn. The best way and quickest way to learn is to collaborate. So for example, you have a technology license to a US company, but then you interact with them, then you, while you're working together, you learn, so you result in win-win situation. I'm sorry, Oriental people, we used to have this type of culture. When you own something, you want to own everything by yourself. And now maybe 90% or 80%. If you tell them, hey, how about 50-50, nobody want to do it. Well, I should not say nobody, but many of us don't have that kind of culture, especially our father generation. So I think that culture needs to be changed a little bit. So I thought this is something that we need to learn from US. There are a lot of things we need to learn, but I thought I just pick up 3 items that it is, I personally feel is extremely important. By coming back to US for 5 years, that's what I feel, that it's a high priority that we need to learn from US. Thank you.
Thank you. So you mentioned cluster, you mentioned FDA, so it's 100 years, and you know, one thing we are very good is that we are very good at catching up, right?
Yeah.
Yeah. So, but you mentioned that this is a very small island, so comparing to U.S., we are teeny. Okay, especially in terms of research budgets and capabilities and the market and everything. Okay, so I'll come back.
Not talent. Well, talent, not too bad.
But we are smart, yeah. But we are smart. Okay, so we can do something. So I'll come back to FDA and the cluster later. So next, I'm going to invite Dr. Michael Huang. Michael Huang is now the Vice President of DCB. And DCB is a quasi-governmental agency in a way, because it's mostly public finance. And they are one of the most important technology incubating center, especially concerning new drugs. Okay, and Dr. Huang has been helping, especially for business development. So I would like to invite him to share with us what DCB has been doing and what responding, you know, to what Dr. Huang just. Oh, okay. Okay. You, both of you are okay. Dr. Huang's. Okay, so please join.
Thank you for
share us your views.
Sure. Thank you for a very kind introduction. I'm very lucky to see right next to the head of Taiwan's TFDA, and she is not 100 years old. DCB is a non-for-profit organization. We are funded, established by our government. And non-for-profit, actually, my daily job is to make a profit for DCB. So it's a business development, okay? We has been established for 40 years, so thank our Dr. Chang, his introduction. In the past 40 years, our core mission is to help the growth of Taiwan's biotech industry. So we have went through a whole many episodes, okay, that happened in Taiwan's biotech industry, including the development of our technology, okay. We focus on new drug development, okay. We have many different kind of modalities, and we also focus on helping Taiwan's biotech industry in business development. And business development, in my view, is extremely important because biotech industry is a heavy capital investor industry. We need to invest a lot and a lot of risk. So knowing the market, knowing the trend, and knowing the good topics, okay, for the future medical needs is very important. And how do we get access to that? Okay, it's equally important. So we help Taiwan's biotech industry with a different capacity, okay, including negotiation, training, and etc. We also produce a lot of alumni. We produce more than 3,000 people who have served in DCP before. Right now, they are spread in Taiwan's biotech industry, okay, serving in different capacity, chairman, CEO, C-suite people, and also basic researchers. From my viewpoint about Taiwan's biotech industry, so we talk about the key element. I think the most important thing is talents, okay? That's from my observation, okay? The talents, we really need good people to do basic, very good breakthrough type of basic research. So we can bring that, okay, to the industry. The second is that we need good people who are very sensitive to the market, who are very sensitive about the trend, about the development. And those people need to connect the basic research and development to the market. As we mentioned this morning, the whole industry should focus on making profit, okay, making money, so that it can be self-sustained, okay, sustainable, so that our industry can grow faster, okay. Of course, Taiwan, we don't have large, very rich education resource like in the United States, but we have good people like myself, okay, educated in the United States and return to Taiwan. So that's a sort of globalized, okay, the people that from different places. We also need another thing is about cultural type, okay, as mentioned by Dr. Hong. We need people who can work together, okay? Teamwork is very important. My observation over the past 10 years is that Taiwanese people, they are excellent. We are researchers, they are excellent. They are individual per se, okay? They are super good. But when you come to the teamwork, when you cooperate together, okay, this is something maybe down in our culture that we have to overcome, that we really need to be a team player, okay, instead of an individual hero, okay. So I think teamwork is extremely important. So these are two things I would like to contribute right now. Okay, thank you very much.
So you think talent and market-oriented view are more important, but you also mentioned a little bit about money and risk, right?
Right.
Okay. Money and risk is the expertise of Professor Andrew W. And I'll invite him later because sitting next to you is Taiwan's biotech industry's most important lady, Dr. Wu Xiumei. Dr. Wu Xiumei once was originally was a scholar herself and later became the dean of the College of Pharmacy of Kaohsiung Medical University, College of Pharmacy of Kaohsiung Medical University. And later, the government invited her to become the head of Taiwan's TFDA. And I believe everybody knows the importance of regulatory affairs. But one thing I need to add, in her tenure during the previous 7 years or so, actually very few people know Dr. Wu has led Taiwan FDA into the international community. Just to mention that we all know in the region we have APEC, Asia Pacific Economic cooperation, APEC, cooperation, yes. APEC, and APEC have many workforce special subject, and she did one of the regulatory part. And also, he led TFDA to become a member of ICH, which is International Consortium of Harmonization for Regulatory Affairs. And also, another regulatory body that is ICMRA, and ICMRA. These acronyms are, but these are all regulatory. So that's welcome. And both DCB and TFDA actually are part of this park. Okay, so later I'll invite Wu Hanzong. So yes, Dr. Wu, please.
Hello, I'm so happy to be here and to talk with you. Just now, Dr. Zhang talked about we want to be one part in international teams. So we do a lot of efforts to attend some association, not only APEC, ICH, IMDRF, ICMI, and we also the third party of EU API units. It means if our companies want to sell your API into European company, it's unnecessary to need any other documentation from our government because they know we have such standards like EU companies. So right now, our API companies can sell their API to EU directly. And we also attend some lab association, and the lab will be very important. You know, Taiwan is a small or tiny country, so we need a lot of friends or partners to help us. And then we have to know some new information, and also we try to contribute some new analytical methods. Recently, we made some impurity or some other methods, and we also not only get from them, we also donate something to them. So we are the association in EU companies and try to be some, we are observers because we are not the EU companies, so we cannot to be the member. But it's okay, I think. If we can be the partners, then we can share some information with them and also get a lot from them. And just now, everyone talk about Taiwan FDA. You made me think, what did Taiwan FDA have done? We just done little things. If you need a license, please come to us. Then we will try to review it. During the process, then maybe you will think we try to criticize you, but not. We just follow the regular requirements and to ask you to fit our requirement. And if you pass that, it's okay. You can get the license. But if you're not, sorry, just prepare, then try to submit again. So till now, if we talk about the Biotech Taiwan, what can we do? We can do a lot of things. Not only the pharmaceuticals, but also medical devices. These two parts, you have to get a license. So in Taiwan, for pharmaceutics, we also hope we can have a lot of novel drugs, but it seems not so easy. For novel drugs, you need to have the new drugs, to have a biosimilar or biodrugs, or some regenerative medicines. But it seems not so easy to get one. But if you can do that, we welcome. So it's one part, but the other part is generics. But for generics, even though our industries try to do a lot about it, but we still need to do a lot because in Taiwan, the market still covered by a lot of foreign companies. It means on our supply chain, we need a lot of foreign countries to have their own products in Taiwan. It seems a little dangerous. The risk is when we need more drugs, especially in some special cases. Maybe we will not get enough drugs. So we hope our companies can do a lot, not only the pharmaceuticals, but also the API. Another part is the medical devices. For medical devices, actually we have very good IT companies right now. They also involve into this path. So we try to do something as we know, because we also have an office to do it that. Such AI offices have helped more than about, I think, is 20 licenses from our local companies. And some of them have promoted their products to other countries. But that's not enough. We need more, and we hope not only have the market in Taiwan, but also can have the international market. So right now, today, I think here, everyone are the important ones in Taiwan, and we hope we can get together and try to do more for it. Thank you.
All right. Thank you, Dr. Wu. Very good job you have done. I think a couple of key messages. One is that the reason that I mentioned all the international activity and also Dr. Wu's description of how her office is trying to help the industry, not truly to criticize what you have not done right, because she also has a responsibility to protect the people, and safety and efficacy are need to be balanced in our industry. So one thing she's trying very hard, recognizing that we are small, so we need to connect to the major markets, especially the U.S., Europe, and Japan. So these are the major efforts. So that's one thing, and her job is not only new drug. Also, because this everybody believes, although this is not the focus of today's panel, but this is also very important because everybody sees that we have a very strong ICT industry and the so-called AI PC and this new generation, which feeds into software, medical devices, and digital therapeutics, so on and so forth. So yes, she is the most important lady in our biotech industry. And finally, but not least, she also moved the entire team to this park. Okay, so this park, we need to recognize that our today's host, Dr. Wu Hanzhong himself is a distinguished researcher. And his lab actually produced more value than most other labs in Academia Sinica commercially, although that's not your mission. So he is appointed as the director of this biotrack, and which sponsored and hosted this demo day. So Hanzhong, I would like you to give us an idea. DCB is here, TFDA is here, so it's a cluster which Professor Hong Mingqi just described. Cluster in itself is important, and here, geographically, can you share with everybody that how important this part is and will be, and what is your role?
Yeah, thank you, Dr. Zhang. Yeah, the National Biotechnology Research Park, NBRP, was founded about 5 years ago. Okay, so as our government want to have developed a new drug, of course, also have an innovative medical device. So it formed this park. Okay, so it operate and manage this park. So the Biomedical Translational Research Center, Biotrack, was founded about 4 years ago. So as we know, it's a new developing a new drug is quite complicated, difficult. So this park is also invited government, or the corporate body like TFDA, DCB, and the National Lab Experimental Animal Center, NRAC. So this part is quite special. It's first integrate interministerial resources. All hope the other fields involve the biotechnology or stayed in this part. Okay, so one is our mission. I had mentioned is new drug development. So as we have listened to the Harvey, okay, and also the Lauren this morning, best important is to create innovative ecosystem. So this also is a few years. I am and our colleague very hard work here. I think 5 years ago I come here. There's very, very few people here, less than 500. Okay, so visitor come here. Why you are 这里冷冷清清? Where so few people here. Okay, so most important is ecosystem. Right now, after 4 years, there's more than 3,000 people here, and also has more than 50 staff company, and also translate more than 30 translation research here. So talk about a robust or innovative ecosystem. Of course, we need to do many important things. This can support the translational research team as well as staff company. So in this few years, we have established 9 very important innovative co-facility. This can help the small molecule drug development, antibody drug development, as well as the gene therapy and the cell therapy. Also have mRNA therapeutic drug. Also have well-established, very important high-end instrument. So it can fully support the translational research team and staff company stay in this park. Okay, but this is not enough. Recruited talent or outstanding research team come to here, and also have strong workplaces co-facility to support. They also need money. Okay, so the reason why we every year we have hold a demo day. Yeah, this is 4th year's demo day. So we want to promote the NBRP, including DCB, TFDA, NRAC, and the biotrack. So we hope every talent or translational research can come here, as well as the investor, like the VC, venture capital, accelerator, and they can come here. We create a platform, they can talk each other, and has create in the future as a meaningful collaboration. I know some research team or staff company has invested the money through this platform. So I also very thanks President Hong. The last year we start is staff companies is not enough. We also have need to select outstanding research team come to the NBRP. So last year I asked Dr. Hong, we need to also screening and pitch the outstanding research team. So he said to me as I so 我们两个来抬轿 okay, yeah. But I say it's not fair. You can see he is so strong. But you can see I'm so thin. But he helped a lot of. Last year we have coordinated 12 outstanding university, and the select is more than 60 team has joined the P team. Finally, from the 30 teams, we select the 5 team. Okay, so later on the 5 team, maybe tomorrow also or talk to the Harvey. Okay, they will discuss about how to translation to form the staff company. So all of this demo day or pitch day is quite important to promote the ecosystem or promote the NBRP. The other is also important, is also my duty, is how to educate the talent. So as we know, most of the research team is from the institute or university. They did not know about a business part, okay, or how to drug development to the clinical trial. So I also are very grateful, like the TID is chaired by Joe here, yeah. He has invited a lot of experts that work in big pharma. And every time come back to Taiwan, then also visit here, then give a talk. It's quite a benefit for all of our staff company and as well as research team here. Okay, thank you, Joe. Yeah, and also has thanks like the MIT. Okay, yeah, this year we have quite honor to invite it for excellent, outstanding researcher come here to teach us. The other thing I think we also need to link to the other part. Okay, because as we know, startup need money, so we also have collaborate with international biopark, like the iPark, Utrecht in US or in the European. Okay, so all of these do is to create the ecosystem. But recently, we also in these 2 years we also found the money to create ecosystem is all from the academic Sinica. It's not enough. Okay, so, yeah, it's only can academic Sinica can provide only the basic operation fund. Okay, if we can more to develop successful first in class new drug, maybe we more need to government's funding. So hope I know it's a very important people here, and you can see also a very important seat on the VIP chair. Okay, yeah, a lot of VIP here, so it can help us. Okay, so also has from the get the money from the government. Okay, so we are very hard to introduce many our partner. Okay, from the VC inventor accelerator right now, I think it's more than 50 partner also here can work with us to invite the startup company. Okay. Okay. So through all of together, I think we can create the robust ecosystem then to accelerate new drug development in Taiwan. Okay. Thank you.
Okay. I think yes. From my observation, I believe you guys have done a very good job in trying to create the ecosystem. But I'll save the comment for Harvey last, because you are mentioning about money, and the one thing, because in our audience we have Judy Zhou, who has just successfully raised some $200 million US Series B, which is just amazing. Everybody give, okay. But most biotech companies, which I know in Taiwan, are still struggling, trying to raise Series B, Series A, or whatever series. And Harvey shared with us that he started to work on rare disease. And rare disease, because of its rareness, because it's only, so in the beginning, it's very difficult to imagine how to finance a rare disease. And researchers internationally, I believe we also have experts from Boston Children's Hospital, right? Okay. But today we had the honor because Professor Andrew W from MIT, a couple of years ago, he had this crazy idea. So it's said that, can financial engineering help saving lives? Okay, so I went to one of his speeches and said, this is awesome. Okay, he is going to share perhaps many of the thought tomorrow here. But today, I want him to specifically share with us his observation, because he is also a member of the Academia Sinica, and specific address in terms of his expertise in this financing and risk management. What is his view about how to help Taiwan's new drug industry? Andrew, please.
Thank you, Dr. Zhang. I apologize for my voice. I've been talking to many, many people over the last few days, and it's a little hoarse, and jet lag has made it worse. So first of all, I want to be careful with my remarks, because I'm pretty sure I'm the least informed of the members of this panel with regard to both biotech and Taiwan. And so for me to comment on how to improve the biotech industry in Taiwan is a very dangerous subject for me to touch. But also, I have to admit that you know, the old saying that to somebody with a hammer, everything looks like a nail, that's true with me as well. I'm a financial economist, and so I look at everything through my lens of financing. And if we put aside Taiwan for a moment and just talk about the world, and talk about all industries around the world, I think it is a true statement that with any industry that develops successfully, there is one prerequisite that has to happen, and that is that the financial investment process has to develop at the same time in order to support it. Because without the money, the progress stops. It's as simple as that. The only people that I know of that can make progress in their careers without money are mathematicians. You give them a pencil and a piece of paper, and they're good for a few years. The rest of us, we need money. And so, as an outsider looking at the industry here in Taiwan, what I think could be very important is the fact that the investment industry needs to be better connected to biotech. There has to be a deeper set of biotech VCs. There are obviously a number of them that have been investing in biotech companies for years. So, and they're quite successful. But it's not enough. It's not enough not because Taiwan is small. On the contrary, Taiwan is very big in many ways. We just mentioned the semiconductor industry. This little tiny island with 23 million people, how is it possible that it is the world's largest provider of semiconductor chips? That didn't happen by accident. And so I see the same potential for the biotech industry. The biotech industry could very well be the next semiconductor industry in Taiwan. But if that is going to happen, we will have to have financial innovation to match the creativity of the people in this country. Because right now, the creativity is outstripping the amount of money that's available to support them. And I think there's some creative ways of increasing that kind of investment capacity. I'll talk about a few of those suggestions tomorrow. And I suspect that a number of conversations are going on right now among the investment community as to how to tap into the resources that are clearly here to be able to support that kind of innovation. So I think it's very exciting, but I do think that there's cause for concern as well as opportunity for improvement in thinking about how to better connect the financial sector with the biotech sector.
Thank you. This is very important, so I hope everyone can join Andrew in this talk. It's one talk you need to listen because it's different. Andrew is from financial economics, which is extremely important. Although Academia Sinica, the most prestigious research institute in Taiwan, is not charged with profit making. But as Harvey told us this morning, that we, as a researcher, we all have this obligation to make our research to be available to the human being as a whole. But having go through this, I saved Harvey for last because I just talked to him that I want him to be very candid because he has been in Taiwan for many times and he has talked to many people sitting in committees and trips and give many talks. I want him to be very candid after these initial comments and all his observations, that what he would give advice, not only to BioTrack, not only to Academia Sinica, but to perhaps the industry as a whole, you know, and all the stakeholders, the government, the industries, everybody sitting here, and Professor Hong Min-chi in Taichung, everybody. So Harvey.
You're asking, is this on?
I'm asking an impossible question.
No, you're asking a very important question, and it has many pieces to it. Just a piece of background. Taiwan is not alone. I work in many countries, Singapore, Japan, even China, I was just there. I was in Paris. I work with a number of American cities, all of which have similar characteristics. Excellent research universities, excellent hospitals, excellent educational systems, but little, if any, biotech or really any other kind of innovative companies that come out of universities. So with the universities, I would start with cultural change and education. I mean, a few examples. At MIT, many of our graduate students in the sciences and in engineering take classes in the business school. Classes in entrepreneurship, finance, on it goes, on it goes. I alluded to the science and business of biotechnology class that I teach at MIT. Now, Andrew and I come from completely different backgrounds. But at a dinner one day, it must have been, what, 7 years ago, we had this idea of teaching a class called the Science and Business of Biotechnology, where we bring together in the class, it's about 60 students, half of whom are MBA students. They might be from MIT, from Harvard, wherever. The other 25 or so are graduate students in biology, engineering, computer science. And we put them all together in a class. And on Thursday, we will have 2 lectures. One, usually a scientist. For instance, in one lecture, I go through the technical details of antisense oligonucleotides. And then I bring in John Maraganore, a business person, also with a PhD, who built Alnylam to a, I don't know how many billion-dollar company, but having several drugs. And I say it's a privilege to teach the course, because I listen to Andrew's lectures, you see. We have recitation sections where a TA from the business school teaches a crash course in finance, venture capital, patent law to the science students. And I have a TA from the science department who teaches the business school students enough science that they can understand. And in the end, the students form groups and write business plans for biotechs. The idea is not to start companies from the course, but rather to get groups who are familiar with each other, who can talk to each other, who have personal connections with each other. So I think it's an exemplar of what can be done really anywhere. And also courses for faculty members. I've been on the board at Boston Children's for what, almost 20 years. And I realized there was such great translational research, but very few companies. And working with their TLO, we started courses for the faculty, just lunch seminars for the faculty on patent law. Most faculty in the sciences have no idea what a patent is, okay? We just start there. What is a patent? What are the pieces of it? What does a patent allow you to do? What doesn't it allow you to do? We're talking simple stuff, but to make our faculty aware of what's going on. So I think there's a lot that can be done internally. You know, this group, just knowing what I do about your backgrounds, this group in the audience could put together several dynamic courses for faculty and students that I think could have profound changes in just motivating people more to think about how they could take either their work or somebody else's work. Many of the companies don't come from your own lab, they come from somebody else's lab. I just heard this lecture. Geez, with what you know how to do, we can start a company. So there are lots of ways of really moving it along. And again, it's not unique to Taiwan. It's the same message I preach. I guess I do preach. All over. Anyway, thank you.
All right. Thank you, Harvey. So it's about culture change because about 10 years ago, Dr. Lian Jiaen, who is sitting in the audience, who went to Harvard School of Public Health, which I also went to many years ago. So he shared with me that in School of Public Health, they are teaching investment, you know, these basic courses. So just as Harvey said that, or you know, in our science, pure science, life science, nobody is teaching about this business, finance, economics, investments, how to put a value for a company, so on and so forth. So this is a whole new thinking, and this is a culture thing, and this culture thing, or this fundamental thinking process change, I think Professor Hong Min-Chi just shared with us in the beginning, but he did not elaborate. So I would like to invite Professor Hong again to this specific, but also I want you guys to self-soul searching. Instead of telling us that what you have done very nicely, I want you guys on the next round to see what you need to improve so that we can do better. As a small island, we can, well, we can never catch up with the United States, but we hope we can ride the tailwind of the US and becoming somewhat another very successful biotech industry big guy.
Okay, today I realized one thing. He likes me. And I'm in trouble. So next time, if he invited me to do something, I just have to be very careful. Okay, I have to be the first one to talk. Then I have to respond to a question on the culture. Okay, I think talk about culture. This is the very fundamental difference between, let me make the domain bigger, Eastern country and Western country. At the lunchtime, I just talked to Harvey that when I was in the US, it is very uncomfortable for me to call my supervisor first name, Peter. Because, you know, in Taiwan, you don't call him Peter. Give me a break. You call him Peter, you're in trouble. Okay? You have to call him Professor something or Doctor something. Well, that's one of the major culture differences. And remember I said earlier that Oriental people, not necessarily to be this generation per se, but in our older generation, there are a lot of very deep concepts that if I own something, I have to own everything. I think that is not what you really to do the successful biotechnology, frankly speaking. I hope that we all agree that many people already say that teamwork is important, and everybody have different expertise, so you need to work together and share the profit together and win, win, plus win. Okay, so I think the culture is different. And I want to also turn to another point that I do appreciate that Andrew said Taiwan is not small, okay? Yeah, Taiwan is not small. Well, especially compared with Singapore. Right? So, but in a way, yes, that Taiwan, we have 23 million population, right? I mean, in terms of territory, in terms of population, compared to US, of course, we're small. But compared to Singapore, we're not small. But Singapore is very successful. So I think we can do something. And the Taijidian, I mean, the mountain which protected Taiwan, that, how to call that, Taiwan semiconductor company, that's one of very successful example. And I think earlier, I believe that Andrew said that, is that you? That you said that in the future, that now if you have this Taijidian, which is so successful in semiconductor in Taiwan, so why not biotechnology? And don't say that we were too slow. My friend, I already mentioned it, that US FDA was established in 1906, and our FDA is established in 2010. We are 100 years behind. And with this 100 gap, now look at it, our current status, we are not too bad. We are not 不及格, okay? We are 及格, okay? So I think for that, I'd like to take this opportunity to, well, thanks to everybody in the audience, well, especially Wu Hanzhong, he has a lot of pressure on his shoulder to promote Taiwan. But well, 你做教，我帮你抬轿, okay? Okay, so I want to reemphasize that. And also the other cultural difference is whenever, I came back to Taiwan for 5 years now, I've seen something very different. Because I was in the US 40 years. And 40 years is almost half century, okay? It's a big difference, a long time. So a lot of stuff, we feel that, how to say that? So when I come back, I hear some professor would tell them, you talk about collaboration, impossible. Or we don't even talk to my neighboring lab because we compete. Okay, if you think this is good for this country, good for your community, I have nothing to say. But if you think that's not right, don't expect the next generation to change the culture. You want to change the culture from us. In the meeting, I said, when I say us, meaning you and me. If you want to change, let's change it now. If we feel it's not right, okay? If you don't feel it's not right, and you think that's right, that's fine. I cannot say anything, but you agree that if you want to change culture, my friend, start it from us. Don't expect our next generation. Okay, so before I finish, hey, Andrew, I'd like to ask a question.
Oh, okay.
There was one time in an occasion like this, that was at a time when CAR-T is one of the most expensive, I think I'm probably right, the most expensive drug in the world at that time, right? At the time when CAR-T was developed, CAR-T is very powerful for treating certain type of leukemia and the lymphoma, now the liquid cancer. But at the time when it came out, my friend, you want to treat CAR-T? $500,000 US. Who can afford it? Well, right now, I think it may be cheaper now. And right now, in US, I know the health insurance or this covers for certain type of patient, which is very nice. Some of my friends actually will survive because of that. Okay, Okay, but there was one time in an occasion like this, I heard from somebody who has an economic background, not scientist, economic background. He came up with a very interesting idea. Maybe you already know it. That is, he said, hey, wait a minute. CAR-T is so expensive. Who can afford it? Maybe James' boss, well, not boss, I mean, James, 台大癌症中心的后面那个郭台铭, maybe 郭台铭 can afford it, right? But not us, right? So that guy say, when you buy a house, you pay down payment, right? Then you mortgage. In the future, if the drug is so expensive, should somebody consider it like a mortgage? Is it $500,000? I cannot pay $500,000. How about I pay $50,000? If I die, I die. I pay on the first down payment. But if I survive, okay, fine. I pay you back in 20 years, 30 years, like a mortgage. That was, I don't know, that was a time when CAR-T just came out, and I was heard about that, a very, very novel idea in an occasion like this. I assume that you guys, oh, you mentioned it. Exactly. Or maybe that was you.
No, you are amazing. You are asking the right question to the right people.
He mentioned it in our class.
Ah, okay.
I mean, the class itself, we heard it for the first time.
So Andrew, would you like to?
Mortgage, huh? Drug mortgage.
Yeah, so first of all, I agree wholeheartedly with President Hung about his comment regarding culture, and I'm going to have a few words to say about culture tomorrow, so I won't say it now, but I agree. That's a very important point. With regard to the point of very expensive therapies, you know, when we look back on the good old days of CAR-T, when it was only $500,000, because today, the most expensive drug on the market, does anybody know what the most expensive drug is?
Gene therapy.
Which gene therapy? Metachromatic leukodystrophy is the name of the disease, and the treatment is called Linmeldy, and it's currently priced at $4.3 million. One treatment, one time. US dollars. $4.3 million. So $500,000 sounds like a bargain, right? I think that this is a really serious issue, and President Hung's point about spreading out the payments is exactly right. And in a paper that I co-authored in 2015 regarding drug mortgages, that was exactly the point. Since you are buying a lifetime of health, as opposed to renting health one pill at a time, that means that you should be willing to pay more. Just like when you buy a house, you're going to pay more than renting an apartment 1 month at a time. The problem is that when we buy a house, we're not expected to buy it in cash. We can spread out the payments. So I proposed drug mortgages. The problem with that is, in the United States, because we have a multi-payer system, you can be in Massachusetts, and if you get a treatment for metachromatic leukodystrophy, and your health insurance company takes out a mortgage to pay for your treatments, that's great, because over your life you'll pay back in terms of the health insurance you're paying every month to that insurance company. But what happens if after 3 years you move from Massachusetts to California, and now you go from Blue Cross Blue Shield of Massachusetts to Kaiser in California? Now Blue Cross Blue Shield is paying your mortgage, but you're paying the fees to California. And so it turns out that as nice as it sounds, drug mortgages actually won't work in the United States. But I've come up with another idea. And the other idea is to use a subscription model where, like Netflix, you pay a subscription fee every month, and in exchange, the drug company will treat you at no additional cost. So I think there are some creative financing methods to make these therapies affordable, and that is another aspect of financial engineering that can really make a difference for patients. I think we just need to spend more time thinking about it and ultimately changing the culture of the investment industry to think more creatively about how to get these amazing drugs that many of you are developing right here at Academia Sinica and get them to patients faster.
The reason we have Andrew here today is trying to help us to think that, because traditionally we believe it's mostly science is in play, but science only is the first necessary step. Science itself will not turn into drugs. So Harvey this morning told us about the obligation. So obligation, this is something that many of us have not heard before. That when I started a lab, work in the lab, and working on a project, I have something new invented, and then I want to publish it. Most of the people in these academic research centers believe this is all what we need to do to publish papers. But Harvey told us that, no, this is not sufficient. We have this obligation, or even moral obligation, that we need to license it out. And then we have Laura told us about how MIT do this very complicated scheme of trying to licensing. Licensing itself is not a simple, you were sitting here, I don't need to repeat it, but one key word I believe everybody's already learned is that licensing itself is trying to, hopefully, one day, this technology will become a product so that the humankind, the world, could benefit from it, from this original technology. As a result, we may profit from it, but it is not our original purpose. I think this concept is so important. That is why I'm so glad that Professor Hong and Harvey said about cultural change, because it's not in our culture, not in our government culture. Dr. James Yang of the Taida IE, the NTU Cancer Hospital, he told me that the government is asking every institution trying to be profitable, which is not wise. So this is one thing we need to have, this cultural change from top, to every institution. So I think culture change itself is so important that, and I also said that we should not be satisfied with what we have done. Although people like Joe Shen has been helping the industry, people like Dr. Wu, is building this ecosystem and getting all the experts teaching us about business development, about the market, and about everything that Harvey just said. Yes, we are, but we are still short of real success. We are still very small. So one thing we need to do is, I often said that we should stop saying that how successful we are. Because by saying that, we seem to be quite satisfied. So we need to be very candid. So one thing, I would like to be candid because I was very privileged to be sitting as the chair of the advisory committee of the BioTrack. So we did a review yesterday. Okay. So the review told us one thing, that comparing to what we aspire to, we are still at this very elementary stage. So, but the Taiwanese companies, many of them are amazing. Many of them are sitting there. I just quoted one very successful model. And Judy just shared with us that of the top 10 best-selling biologics in the world, she participated in 8 of them. So she is going to make a slide in her next presentation. We have many, very experienced from big pharma, sitting in the audience, also working in the industry. So we have many talents, and we still need more. But Harvey said that, no, these are the leaders. You need bench workers. You cannot, who is training the technicians and everything? So these are the things that as a whole we need to learn. And we still need to convince people, such as Andrew will show us, how can you minimize the risk and trying to pull the risk so that our success rate will be better. And the investors, because the investors always ask, how can they get their money in return? So this is something I think we need to do, is stop praising ourselves how successful we are. Yes, we have done quite a good job comparing to many places, but as Harvey said that, we still have a long way to go. Many places are trying to copy. So let me ask us the final question. Harvey showed us a map before and after Kendall Square in Boston. If you guys been to Boston, you know Kendall Square in Boston. Okay, 200, 300 companies there. But before that, it was intended to be something else. This place has been built. If you walk around, there is a path across the hills that will be the Nangang Santie Gonggo. And under that hill, a tunnel has been dug. And sooner rather than later, this place to Nangang rail station will be only 10 minutes or 15 minutes by walk. So this is a place. And with the high-speed rail, we can go to Hsinchu, we can go to Taichung, even Tainan. So Taiwan itself is a cluster. So with the remaining time, I would like everybody to say something you think we need to change so that we can be more successful. Okay? I'll start from Michael.
Yeah, it's a very good discussion. Thank you. As I learned that the culture is very important, okay? But my daughter, okay, always advised me that only old people talk about culture. So they are looking for things that is, next generation, they are looking for things that is really cool and that's really for the future. So that's something I really have to learn from them. I think, something that we should make a change is that one thing is about our mentality. Okay, as I mentioned about the heart for teamwork. Okay, actually, if you look at the teamwork, it's down to the bottom layer. It is respect. Okay, respect other people's work and your work, and you know the good position. You know how to cooperate. That is very, very important. Okay, and I really would like to see in the industry that there is more cooperation, not only among Taiwan but also with other countries. As we just mentioned that, if you look at the Taipei Basin, okay, it's about 376 kilometers square, and with 5.8 million people, and we have a financial center here. We have the 2 airports, 2 seaports, and 10 research university and clinical centers. So this huge, gigantic, marvelous biotech hub. So we really can cook out something. But how? okay? How is a very important thing. So I still think that training for good talents is one of the things that we should make. We should really put attention on this, okay? And also, as I mentioned again, that not only technology is extremely important, but also the market and the business. So that is a part that you have to explore. You have to also have an interaction with the world, connected to the world. You know, everybody talk about sitting on the shoulder of a giant, okay? Nobody talk about being stepped by the giant and crush. Between the crush and the shoulder, okay, it is a business development. Okay, that's my view. Okay, so how we train the young people that can grab the two sides. One side is on the importance of technology development. The other side is the future market, and so also connected to the Mr. Money, a money engineer here, financial engineer here. Okay, that's very important, right? So that's my viewpoint. By the way, I'm very happy to see there are engineering professor here. Myself was an engineering professor, so engineers, we establish, we build up things, we solve problems, and sometimes we create more problems. So I'm very thankful that for this opportunity to share my view. Thank you.
Okay, Dr. Wu, short comment.
Taiwan is a very good place. Taiwanese is wonderful. But I think we need to enhance something. For example, the teamwork, cooperation. So if we can cooperate each other, then try to do something better, then we will have a good achievement. Thank you.
Thank you.
Andrew? I'm going to make 3 suggestions.
Okay.
The first suggestion is that Taiwan should change its laws so as to allow faculty members to start companies without having to leave academia. That's critical. Second, Taiwan needs to raise a $1 billion US dollar early stage translational investment fund. And third, Taiwan's researchers need to stop thinking that they're inferior and think that they're 100 years behind. You may be 100 years behind, but the beauty of technology is you can now leapfrog where the other competitors are, and there's no reason why Taiwan can't actually be a leader in certain areas of biotechnology. And my nomination is to create a company called the Taiwan Gene Manufacturing Company, TGMC.
Okay.
That'll be the leader in the world.
Okay. Harvey, you want to go first?
No. I've learned over many years to be a good listener. So I'm very happy to listen to the comments of the others. I've already said more than I should.
Okay.
Thank you.
Okay. Yes. You want to be last?
Well, I do want to say something. Okay. I'm not asking that to change culture. So he asked me how to change culture. I want to remind you another country, Denmark. You know which one I'm going to talk about? The company called Novalia. Okay? In Denmark, population is 1/4 of Taiwan. And that company, one drug, become mountain of the, to protect the country, just like our Taijidian, okay? Well, the same. But I want to re-emphasize one more time. That is another 100 years we're behind. The company was established exactly 101 years ago.
Yeah.
1923.
1923.
Okay, 100 years ago. So don't think that they suddenly just come out of that result. No, they have been incubated for a long time. Yeah. So we have a lot of things to catch up. So, well, I'm a professor, okay? And in a university, I teach the student. And students usually like to say they. If I ask something, they, 他们. So I told them there's no they. If I say anything, it's us. Us meaning you and me, period. Okay, so you want to change, it's us. It's us. We need to change. And keep in mind, we are 100 years behind. Our FDA is 100 years behind, and our those Zhou is also 100 years behind. We need another Zhou in biotech in Taiwan. I think that's what we need. Okay, thank you.
Yeah. Change culture, I think everyone talk about change culture, but only one I will just mention here is how to encourage our basic researcher. Okay, as we know, the many outstanding researchers in academia Sinica as well as in the university do a very good science. How to encourage them to translate to the useful product, useful drug. Every time I talk to them, your innovative research is a publication paper, but it can change. It's valuable money paper that can save life. That's all. Thank you.
Thank you. We still have a couple of minutes. I'd like to entertain some comments from the audience. Anybody? Yes, Judy, please. Thank you. It's very nice to have you with us.
Thank you. I think I made a comment yesterday about one of the very nice culture of Taiwanese is whenever things goes wrong, we blame ourselves. And I can see also you put everybody on the spot about to see what we all should improve further. But I think one of the important topics about the mentality, because the whole three triangle, the science, the talent, and the capital, needs to be there to help the biotech to grow. And we here are talking a lot about the science, the talent. I'd like to kind of getting some comment about the capital, because I think, like Andrew mentioned, we should just touch a little bit about when we want to change the mentality, it's not just a scientist, it's not just the talent of the group, but we really need to bring the capital group together to understand the life science investment is different, particularly in Taiwan's environment towards a high tech, because that's definitely a different timeline. That doesn't mean it's worse. And I personally don't think making money is a bad thing anyway. So I think, so in any case, I like to hear some comment or any suggestion how we can help the capital side, the VC side, to also come along with the mentality change. As Hongren, you asked everybody to say, what are we going to do different? I think that's probably the other perspective.
Yeah, thank you, Judy. I think the best person to answer your question is the person sit just behind you. Sherry, about capital market, that's what Judy.
A lot of good old friends here. In matter of fact, I don't think Taiwan is lack of money. There's a lack of connection. We have a lot of people with a deep pocket, but they're not sure which one to invest. There is a lack of confidence because we don't have exemplary examples that making a lot of money. Because personally, I consult with quite a few different companies. There is never a lack of money, it's how you try to look for it. So I think if we have a kind of alliance that is trusted by the people who have money, that they can go to, either the people have money or the people looking for money that can get connected, then it may be a good environment and a lot more easier. Thank you.
All right, Judy, yes.
Can I also make a comment on that? So
yes,
definitely, absolutely, and myself, I'm so sure everybody in this room doing the biotech business, not just for money or not for money. I think we should always start not having the money in the mindset. However, exactly like Sherry just pointed out, right? When you try to talk to a group of investors about, oh, this is not about making money. Good luck, right? So I do think, I do think somehow we need to help people understand this is going to, I know it sounds so controversial, but really to encourage you about, hey, this is going to make money.
Okay. We'll make a distinction here. Thank you, Judy, for clarification. I believe Laura is saying that the mission of the university, when they are doing licensing deals, their mission is not profit-seeking in itself, okay? But for the biotech company, if you want to attract investors, you need to be able, just as Andrew, you need to be able to convince that we'll make money. And we do need, as Sherry said, that we do need successful stories like yourself and others to show to the investors that it makes sense. But also, people like Andrew, Professor Andrew Low, from this financial engineering, he actually has injected brand new idea how to minimize the risk so that investment itself makes sense to investors. Because we used to tell everybody that, new drug investment is extremely risky, and it takes a long time, to have return. But Laura told us that other technology may have this similar situation, not only new drug. The one thing. So please come back tomorrow morning for that lecture. That is important, how financial engineering is going to help minimize or reduce the risk so that we can get money out of Taiwanese rich man's pocket. With this, I thank you for your attention. Thank you very much.
Our distinguished guests, please remain on the stage, and I would like our photographer to take a group photo for you. Everybody, please be seated. 好，我们谢谢大家，但是请大家可以入座先拍一张照，好不好？我们先坐着。Everybody, please be seated, and I'll ask our photographer to take a photo for you. All right, please look at our photographer. 3, 2, 1. Okay. 好。So everyone please rise, and I'll ask our introductor to come back to the stage and take a photo with you. 好，我们请李文山副主任回来到台上。Everyone please get closer. 请大家靠拢一点好不好？好，我们看一下前方摄影师。3, 2, 1. 3, 2, 1. All right, thank you very much. Thank you. Now we'll take a break, and the next session will begin at 3:50. 3:50. Remember to return to the venue on time. Thank you for your cooperation. 中场休息时间，那我们下一场议程会在3点50分准时开始，请大家记得要回来到现场。感谢各位的配合，谢谢。
位于台北市南港地区的国家生技研究园区，成立于2018年10月，紧邻中央研究院，周边还有南港软体经贸园区及12家医学中心。南港生医聚落的形成，将扩大群聚效应，更快速地带动产业的发展。
国家生技研究园区的成立，是以推动国家生技医药发展为重大责任，以强大的研发能量为基石，将重要的转译研究成果转化为促进人类健康福祉之重大价值。
开发过程，并将生态保护视为首要任务，在生态保育的工作做了最佳的示范。国家生技研究园区是国内第一座跨产官学研共同进驻之生医研究园区，以中央研究院之研发能力为主轴， 并引进与生技产业发展相关之政府机关进驻，期待在产官学研共同努力之下，将重要的研究成果转化具社会价值的产出。首先，中央研究院生医转译研究中心进驻于园区的 A、B、C、D 栋，以转译医学与生技制药为发展主力，并负责推动创新生技平台的发展。经济部财团法人生物技术开发中心进驻于园区的1栋，专精新药临床前开发与转译价值服务。卫生福利部食品药物管理署进驻于园区的 F 栋，主要提供医药产业辅导、法规咨询服务。国家实验研究院国家实验动物中心进驻于园区的G 栋，提供多元化动物资源及试验服务。因应国家生技研究园区的成立，中央研究院特别设立生医转译研究中心，并于2019年9月进驻于国家生技研究园区。
生医转译研究中心的成立宗旨是要建构一个强大的生医产业生态系，协助生医新创团队将创新的基础化研为用。
生医转译研究中心设置有4个专题中心，共同执行推动台湾生技医药发展的任务。转译医学专题中心的任务在引进优秀团队进驻园区，进行转译医学研究，除提供核心设施与关键技术服务，同时建制完善的生技产业生态系，全力协助新创团队化研为用。转译中心目前所提供之8大核心设施包含：1、药物合成及分析；2、人类治疗性抗体研发平台；3、RNA 技术平台与基因操控；4、mRNA 先导研究核心设施；5、台湾小鼠诊所；6、生医转译核心供仪设施；7、感染性疾病核心设施；8、台湾人体生物资料库。新兴传染病专题中心的任务，在整合中研院具传染病研发专长之各领域专家，建立传染病防治研究之各项技术平台、动物模式，及建制国家级 P2、P3 实验室。智慧医学专题中心任务在建制医疗影像、多体学与 AI 大数据分析基础设施，建立预防或早期治疗以及精准医疗的资讯平台。国家生技研究园区另设置创福育成中心 BioHub Taiwan， 由创福育成专题中心营运，主要任务在打造园区生态系，孕育国内生技医药的新创团队及企业，并链接国际生医加速器计划以及国家生技研究园区学院的人才培育。国家生技研究园区加速建构我国尖端生技产业之基础及动力，除了造福国人的健康与福祉外，并要以生技制药带动台湾新经济的起飞。
back， 欢迎现场的贵宾回来到我们的活动。Today's final session, Trans Forum 2, will feature Dr. Tao Mihua, Executive Director of the Translational Medicine Center at the Biomedical Translation Research Center of Academia Sinica as the introductor. And the session will be moderated by Zhou Shen, Venture Partner at Vivo Capital. 今天的压轴场次就是趋势论坛2，会由中央研究院生医转译研究中心转译医学专题中心的陶密华执行长担任引言人，并且由美国维吾资本投资公司创业合伙人马海怡担任主持人。那首先呢，我们就先请陶执行长为我们做引言。First, let's welcome Dr. Tao. 好，请大家给热烈掌声。
Yeah, welcome back to the second forum of this afternoon. And this forum, the topic is the impact of academic tech transfer process on the success of a new drug. And we have 7 experts in this area to share their experiences. And let me introduce our moderator, Dr. Zhou Shen. And Zhou is received a PhD in chemical engineering and has 20 years biotech company experience in US and another 20 years in Taiwan. So she has 4 experiences. So welcome, Zhou.
好，那我们欢迎几位贵宾到台上来。Welcome our panelists. Lawrence C. Foster, Associate Director, MIT Technology Licensing Office, 麻省理工学院技术授权办公室副总监，还有梁启明，中央研究院生医转译研究中心客座讲座，邱文聪，中央研究院制裁技转处处长。廖成威，经济部智慧财产局局长，还有周慧全，美国全新医药生技公司总裁兼执行长，还有 Alice Chen， 美国生命科学合作伙伴加速器执行副总裁。
So we have girl, boy, girl, boy, girl, boy. Okay, that's fine. Okay, this is my only contribution to this session is to make sure equal opportunities. Okay, good afternoon. You're probably, if you're still staying here, you must be my college classmates or elementary school alumni or something, right? give me the last boost for this session. It's our pleasure, and we have got to know each other very well. I just have to tell you a story so that you remember this bunch, okay? I have been, for some reason, in the last few years, I've become a professional moderator. Whenever they need somebody to fill in the gap, fill in the space, they call me. And I say, what am I supposed to do? Oh, this is your topic, and here are my panelists. So I have nothing to do with selecting them, but they are beautiful. I could never approach you by myself if I had to do that. Okay, so I have had a very easy job because the good work have been done by BioTrack people. I thank them for helping us. We started getting together on email first, of course. Then we said, well, we got to know each other a little bit so that we feel comfortable sharing our own experiences. So on a very important day, we got online. All of us sat there talking happily, actively. All of a sudden, 3 guys it's really interesting. 4 women were not in Taiwan. You were in Singapore. We were in California. You were on East Coast. The 3 guys happened to be in Taiwan. And then, all of a sudden, 2 of them disappear. Then I heard something, oh, earthquake. 2 of them immediately hid under the table. But they continued talking, okay? And this gentleman had 2 assistants, happened to be women, sitting one on each side. probably holding him. And he was the only one sitting there the whole time, okay? So you were very brave, but I know you were sweating pretty hard, okay? But it happened twice. It didn't just happen one time, remember? Then all of a sudden, here comes again. And the two guys disappear again. They all hit under the table and continue talking. So I really admire your dedication to BioTrack seminar here. And we, through life and death experiences, we became very close to each other, okay? This exercise, I actually felt very interesting. It was so, I look at the title for the previous session, Hongren had it, okay? If you remember the topic of his session, probably don't remember that. Oh, this is right. No, this is our session. I said Hongren's session. He said the key, my glasses, the key element to, what is it? To accelerate drug development and enhance its success rate for biotech industry in Taiwan. We are talking about almost the same thing. It's like we're providing the answer. Right. We're providing the answer, which is the tech transfer process. A smooth tech transfer process. All other things are important. Money, people, everything. But if everything being equal, what can we change without going to the government asking for more money or going out hiring different people or whatever? I think this is what we're dealing with. We can deal with the challenges with existing talents and wisdoms, and it's a matter of recognizing the important position where the tech transfer is positioned, and also what tech transfer includes. I think we should stop calling ourselves TT group. We should talk about ourselves as TLO, Technology Licensing Group, right? So the licensing word makes life and death difference. If we were only looking at patent, managing patent, the patent will be always just patent instead of turning that into an applicable medical solution. So I think that is, in a nutshell, that's why we are trying to put our arms around it and trying to understand what can we do differently. Now, you have the name and all the beautiful pictures there. Okay. I think Judy is the most beautiful because she has money. Look at the confidence. Look at the confidence, the look of a confidence. Money is in my pocket, okay. All right, I'm gonna be doing a little bit differently. I always say that I'm an interviewer. I'm gonna be showing my back to you. And I wanna look at them, okay? Okay. Today we have collections of all the experts here. When we talk about patent for so many years and so many times, have you ever met the guy who's in charge of the patent, the bureau head of a patent office in Taiwan? I don't think too many of you have met. Have you? Oh, that's nice. Okay. This is my first time to meet you. So, well, it's my honor. And you're so friendly. I didn't know that. I thought patent officers should be very strict, right? But I think you have been in this position for a long time. You have seen many things, and then of course all of you have listened to Lauren, excellent talk. I just keep thinking one of these days if we could show the fact sheets that you were showing somehow, then we got our goal met. Okay, and most important the head of patent management process and everything,邱文聪,邱博士,邱律师,邱大律师, okay, and so it's our honor. Of course, everybody by now knows you don't need a publicist in Taiwan. Everyone become your publicist, okay, Judy. And Liang Qiming, Liang 老师 was, ever since I have started coming to Taiwan, I always wanted to work with you because I heard about your name when I was just young, okay? I grew up with knowing you are in charge of a very important process, and it gives me the pleasure really to finally being able to work with you. And Alice also has an enormous amount of experience for the so-called project incubation and the technology transfer, and venture building, and investment. All of us, and she's still so young. Okay, everybody's young to me. Okay, now we told Hongren the most important, one of the most important answers to his question is the tech transfer process. If the tech transfer process is done right, then you have a better chance to have a successful new product developed. Okay. I don't know how to do the analogy. It's like having the right parents. Then you have the gene properly allocated, and you gave them the nurturing, the food and shelter and love and everything, and they grew up nicely. And we're trying to be that nurturing part, right? And so if a tech transfer process all of a sudden became a gating factor, became an obstacle, then I think that is a trouble. So our discussions here center around the experience sharing from all of them about what we are doing in patent management, how we handle some of these the challenges, and what needs to be put in place to make it work. So the first section, we're going to try to center all the discussion around patent, IP, application, and all of you have been handling that, dealing with that from different perspectives. From the industry, which is represented by Judy, you're the recipients, right? And we have both, I think Lauren and Alice have been doing the, and so is Liang Lao Shi and Wen Cong. You are the one handling the transaction. And here you are the judge. You have to, you guys kind of like defining what's right, what's wrong, right? Okay, and you've seen so much. Okay, so I think we did a little rehearsal. That we have a cheat sheet here. Okay, a little script. Actually, it's a collective work from discussion, from brainstorming. We'll put down. We will try to touch on 4 subjects actually. The first one is patent strategy, basically. The second one is project incubation. Once you have the good patent strategies, but if the projects are not incubated properly, you couldn't take the advantage of the patent. The third is actually business development. This is a sensitive subject because in certain organizations, they don't think they should be involved in business development. But the business development is not what we usually call it business development. What we're talking about is how do we create a scientific exposure of your asset to the right audience? Okay, the audience could be the head of R&D of certain big pharma, or of course to their BD people also. Then the fourth one is called venture building. The reason we put all this together is without the project incubation, without the business development, without the venture building, all the time we spend on patent strategy is going to be wasted. Okay, so we could not really just talk about patent without also understanding the other elements and how important they are relating to each other. Okay, I'm sure in the audience, many of you have experiences in dealing with the entire process, or maybe part of that. And your experience could be very pleasant, I hope so, but I see people shaking your head, okay? Well, maybe in certain places we need to just find out where the glitches are. Why didn't it work so smoothly as we expected? And hopefully, after the panel discussion here today, you go home, you pick up something from here, and then go home and make a change. And make it work. Okay, so don't fall asleep. I'm going to have a final test before we leave, okay? Okay, coming back to patent, all of you have experience in dealing with managing or filing patent, managing patent. Why do we have patent? Okay, it's a million-dollar question. Why? It may sound very simple, but it may not be that simple. So I would say, ask maybe a few of you to comment about your understanding, your interpretation of the reason why we have to have patent. And then coming down to how to file the patent, when to file the patent. How do you determine your patent applications are successful? Okay, now you go into a deep thinking. Don't fall asleep. Okay. All right, I'm going to start with 梁老师。梁老师，我叫梁老师对吧？陶老师，我可不可以叫他梁老师？可以哈 ，OK。因为陶老师是有 trademark 的专有名词。
Can you hear me?
Yeah.
Yes. Okay, I think the very important thing for a technology licensing office, the first thing, they should be able to identify what is the most important invention in that institute. Okay, so identify the good inventions. And then they should file for the, decide whether they should file for the patent or not. And in other words, they should identify the invention and then decide whether they should keep as a tangible or intangible property. And if they found out that it's really worthwhile to file for the intangible as an intangible property, and then they should decide whether they should keep it as a, like the know-how, trade secret, or to file a patent to protect it. Yeah. So what's your question? Oh, okay. When to file a patent? And only after all the consideration, and then they can decide whether they want to file a patent or not. But in order to decide whether to file a patent or not, they should make sure that it's new, okay, and it's useful, and it's really worthwhile to file a patent. And most important, they should make sure they have enough money to file for the patent. Yeah. So roughly something like...
costs a lot of money.
Yeah, roughly something like that. Yeah.
That's probably the most difficult part. When the company just started or the project team just started, you have limited budgets, but you have to spend that for the most important activity, right?
Right.
Patent filing and submission and maintenance.
Yes.
Yeah, right.
Okay. But that's only the first step. And then they, of course, they have to have the second step, is whether consider whether the invention, whether the patent can be licensed out. Okay, so that's the second step. They should evaluate that also. Mm-hmm. And then the third step is to make sure that the invention can be incubated and can become, to go forward. And the fourth step is to make sure that it can become a marketable final product. But in the first step, it's very important is to make sure that whether you want to file a patent or not to protect it. For academic institution, I think the first step is enough. But for the industry, of course, they have to make sure to the second step, the third step, and the fourth step. And the reason why I say the academic institution, the first step is good enough is because the experience in the United States. In 1975, America was beaten badly by Japanese. And I think everybody knows that if they are old enough, like me. Okay, I still remember when I went to America, the America was very bad economy beaten by the Japanese. And the reason was because the America, they do the research, but they didn't file for the patent. Okay, and finally in the 1980, the Biomedical law encouraged all the university, all the academic institutions in America to file for patent. Okay, and that's then turned the table. And that's the reason why Japanese no longer occupied all all the finding, all the the products and all the IP. Okay, so that's very important. So for the academic institution, it's very important to protect your valuable invention.
Yeah.
Thank you.
I think you touched on something very interesting. You said if it's academia, people filing patent, just the substance, whatever the critical invention part is enough. But if it's for industry, you have to think about the business strategy. Okay, but in Taiwan, all the drug discovery, the inventions, have been done by the academia organizations. If you only file whatever that pertain to the science, and not thinking about the big potential market, situations and business competitions and other things, then you think a few years later, you want to, whoever the technology has transferred to, let them do it. Does that work?
No, I think I should make it clear. When I first came back to Taiwan, that was back in 1997. Okay, that's about 26 years ago. In Taiwan, the only place to file for patent for the academic institution is Guokehui. How do you say that in the National Science Council? And yes, and so no patent at all. And for the first step, if we want to really encourage the whole biotechnology industry in Taiwan, we should give them something that they really can start with. So at that time, we decided that we should protect whatever the important finding first, okay, and then consider for the, because if you really like to do the protection, and then immediately you know how to license it out, immediately knows how to develop it, and immediately know how to market it, it's impossible. Almost for all it's like a technology office, licensing office in Taiwan. In the very beginning, no technology licensing office. So the first step is really to encourage people to protect it. Just like in America, back in the 1980s. You encourage the university, you encourage them to protect their IP. And then later on, then everything will go smoothly. Then they learn how to license it out, then they learn how to develop it, and they learn how to market it.
Okay, thank you. Well, time goes on. Now we are evolving from the 1980s to 2000 something now. Okay, Wen-Cong, so what's your experience in some patents were filed, timing is wrong or right, or what do you consider as a successful patent application?
Okay, I'll start with the purpose. But I would like to say that I remember that's April 2nd.
April 2nd.
April 2nd, when the biggest earthquake hit Taiwan.
Third.
Yeah, is third or second?
Third.
Third? Oh, okay, third. Anyway.
Second in the U.S.
Okay. Well, ever since then, I just try to prepare my answers on this cheat sheet. Because I'm afraid that another earthquake will hit, and that we couldn't stay on this stage, and we'll leave this answer to everyone here. So I'll start with the purpose. I think the purpose of filing for a patent is to facilitate dissemination of the technology. And only when this purpose is served does filing for a patent make sense and becomes necessary. So this view might differ from many researchers, because many people think that, believe that the research outcome must always have IP protection through patents, and that patents serves as indicators of research success. However, if I may, I think that in the following situations, filing for a patent might not necessarily help with the goal of dissemination of technology. I'll give you two situations that I think is not necessary for filing a patent. The first one is that if there are technologies that should remain in the public domain, for example, research tools, maybe Lauren can comment on that later on, because I know that CRISPR is a research tool, but still you file for patent. So that's kind of controversial, but still I think there may be some technology that should remain in public domain. And the second scenarios that I think that filing patent is not the right approach is when there are technologies that are better to be protected as trade secrets. I'll give you two examples. The first one is if the technologies that once disclosed are easy for anyone to implement, but hard to prevent others from using. In this kind of situation, filing for patent is not smart at all. You better just keep it as trade secrets. And the second example is more common in our institution. It's the very early stage technologies. We all know that for therapeutics drugs, the average development time from scientific discovery to successful approval is around 10 to 12 years, and some would say that it's 15 years. But on the other hand, the patent is valid only for 20 years, right? From the filing date, and sometimes can be extended up to 5 years to account for the time taken to obtain the the regulatory approval. But if a patent is filed too early, prematurely starting the patent term clock, while the technology still requires long time to complete development, then the remaining time, patent protection period after approval might be too short to create enough incentives for commercial investment in early drug development. So making early stage technology transfer become very difficult. So when is the best time to file a patent? Some pharmaceutical companies maybe would opt to protect early research filing as trade secrets and file for patents even after they enter into the clinical trial stage, so to maximize the patent protection. But that strategy is almost impossible for research institutions such as Academia Sinica, because we have pressure to publish. You publish or you perish. So everyone knows this. So, but still, I think I should remind that if only something like a proof of concept or in vitro data is available, without further lab verification of in vivo data, disclosing this kind of technology and filing for a patent can significantly reduce the chances of successful tech transfer later on. So the filing for this type of technology for a patent is not smart, to my understanding. So the last question is about how to measure the success of patent application. I think the success of patent application should not be judged solely by the percentage of granted patents among filed applications. With a good patent law firm, and regardless of the claim scope, patents can eventually be granted in any way. But instead, I think the success of patent application should be measured by whether the patents can be successfully licensed and transferred. And currently, Academia Sinica aims to maintain a 40% success rate in technology transfer for those granted patents. Okay.
Very good. Now we want to ask Dr. Liao, who watched things coming, things going. You must have a lot of observations here about when to file patent and what makes a successful applications and so on.
Okay, thank you, Dr. Ho. Because as I served for the Taiwan Intellectual Property Office about 30 years, I began as a patent examiner. So I would like some experience or my observation about how to protect your research outcome or research achievement. Just as the
邱处长 say， 还有那个梁老师 say， in the technology transfer or technology also license, maybe some outcome is related to the patent and some related to the trade secret. However, in this section, I would like to say something and my observation about the patent filing. And then because, you know, in my observation, before drafting such proposal or the concept, I think the researcher or the professor in research academic institute either rely on their academic research experience or they search through journals they frequently to submit and to make sure whether this topic, the research topic has already been published. However, since you know the patent technology are close to the commercialization, so the commercialization stage, so compared to the academic papers, so I think I highly recommend it should be to include the prior art search, the patent prior art search before you drafting your research proposal. And then I think if you research did some search on patent prior art, I think it is not only help avoid wasting development resource, but also distinguish between the saturated red ocean and the untapped technology area. So I think the pre-R&D patent prior art search not only help identify between the red ocean or the blue ocean, it help you to find the technology niche. For example, and also it can help you to evaluate your patent strategy or your academic outcome strategy, technology strategy. For example, based on the prior search results, and one can assess competitor and their technology strengths and seek. And maybe you can seek a partnership to erase the technology gap. For precise the patent search, I think it is comprehensive understanding of the technology domain and the relevant search skills are very important and essential. So it is highly recommended for organization. Maybe you can set up and establish your internal search team or commission some professional patent search agency. For example, in Taiwan, we also have some resources such as the Patent Search Center. I think it is very available for you to this purpose. And I also would like to share some observation and some my experience. For example, during the pandemic, there are clinical doctor in Hualien who designed intubation box based on his practical experience. He also very happy to share the design drawing online and free for download. However, a subsequent patent search it revealed that the technology for the intubation box had already been published as early as 2004. So I do suppose and suggest when you drafted a proposal or concept, maybe you can submit, you search your your academic journal paper, scientific paper, and maybe you can have some concept to search some IP office, the patent database. I think maybe it can help you find what's your technology niche. That's all. Yeah.
Thank you very much. It's interesting. When I prepared this question, actually, I was having some bad thoughts in my mind, okay? Because if you ask the general audience, why do you want to file a patent? Of course, for my promotion, for my job upgrade, right? None of you say that at least. Okay, that's good. However, that's reality. And that doesn't matter where you are, you know, I mean, the researchers have certain ladders to climb up, and publication, including patent applications, are part of it. The other thing I was also just thinking quite interesting when someone said that not all technology should be patented, right? We understand that, we understand trade secrets and so on. Just think about, assuming you have technology like that in Taiwan, you want to license to a industry, private sectors. Can they raise money to do you think they have a hard time or easy time to get money for technologies they have no patent? You know, in Taiwan, that's one thing, just keep that in mind. Next time when you see an investment proposal and there's no patent involved, don't just throw that into the trash can, okay? That may have something very valuable. In the US, many companies now, when they form a company, they don't tell people. They said, we're starting a stealth company, 隐形的飞机 stealth company, right? Because they don't want the people to know what you're doing, what they're doing. Because it's so secret, so secretive, which is a part of the things that we have rarely thought about it. Yeah, so either job promotion or because it's so confidential, can tell you. That's something I think it would take a little time to get people, I would say, take a little more time to get used to, but I'm sure that's very common in the US, right? More or less. Yeah, it's on.
It's on. It's a very interesting observation on sort of when to file a patent, and from our perspective as academics, I think is a very different perspective than companies, and I think we should draw that distinction of, you know, it's somewhat antithetical to an organization whose role is to teach and disseminate knowledge and publish, to promote keeping trade secrets, which in the United States actually has a very high bar. It's not, I'm not going to tell you, we joke about sort of one of the most valuable trade secrets in the history of the US is Coca-Cola. And, you know, you imagine, you know, Alice has one key, I have another, and Joe has another, and we have to show up together and, you know, each use our key to open the box. It is a very high bar to keep a trade secret. But you're absolutely right. I think when you look in the private enterprise, holding certain information back gives a company a very distinct competitive advantage. But I would also challenge that we should be looking at patents as one tool. It is the beginning. We don't look at patents as a single occurrence. You have an invention, you try to cover what exists on day one, and then with your investigators, you try to think, well, what might you be doing this? What is your future research going to look like? And you start actually planning for how you might seek follow-on patent protection. And then, as we've sort of heard from many of our panelists, then when you're licensing, you're combining different assets together. Some is confidential know-how, some is patents, maybe there's copyright. And so these are typically, a patent doesn't stand alone in terms of creating value for a company. It is a portfolio, and it is really the beginning. And we like to think about sparing room for further follow-on patents and not drafting, I think from the intellectual property examiner point of view, not drafting it so broadly that you discourage and create an inability to file subsequent patents.
Well, Alice, maybe before Alice speaks, I just want to introduce her with a little bit more information, because she came from a slightly different background from the others. She is with a firm called Accelerator Life Science Partners, which is an investment company with a capability of incubating projects, helping the projects to grow, the venture building, plus investment. And they actually were ahead of a flagship pioneering in a certain way. They started from where?
Early 2000s in Seattle.
From Seattle, and then moved to New York, and then how long have you been in Singapore now?
I moved to Singapore about 2 years ago.
Huh?
Yeah. Our company has been in Singapore for about 2 years.
Okay, yeah. So listening to what they're talking, you must have something also close to your shop, right?
Yes. So yeah, from an investor and also company's point of view, for us, especially for our industry, we're a very intellectual property-based industry. It's a highly regulated industry. And so having IP is critical to what we do. And IP is intellectual property. It could be trademark, it could be trade secret, it could be patents, and among other things. To the question, in terms of trade secrets, we have actually transacted companies to pharma companies with parts of the company being trade secrets. And usually the differentiation between the two is whether it's a platform or an asset. So a lot of times, platform technologies, for instance, identifying targets, identifying parts of the asset that will be developed would likely be, could be trade secrets. But what we then do is that we use that trade secret to very quickly drive it to an asset, which then can be patented. And at the end of the day, when the technology is being transferred to pharma companies in an exit or asset sale, it could be a combination of trade secrets and patents for composition of matter.
Great. Well, Judy, from your recipient point of view, you have some personal experience of seeing a patent really was so superbly, so clever. The strategy was so good, which created such a miracle in the business. Have you had any this kind of experiences?
Thank you, Joe. So, Joe particularly referred to, I want to clarify, because definitely my current company, UltraBio, we are just 4 years old. Of course, I have a long history before my time in Taiwan. So that's not the company we are actively doing licensing in yet. But this is probably bringing my experience in the past, being working in big pharma, being there, like making decision about what we're selecting in. So starting from what Joe just asked me, and many of you, thanks Horan for advertising for all my prior experience. So I have this luxury. I really think I was super lucky about when I first entered industry, and I worked on this little tiny project at the time. It was called D2E7, and that was entering phase 3, and that became today's Humira. So then Humira, as you saw before the COVID vaccine, it is the top one biologics, to be fair, because the COVID vaccine is no longer having such a large volume, so Humira still owns this $20 billion every year, the revenue. The smart thing, I cannot claim credit, but I would say my team member has done at the time when we were doing the early development, thinking about how to strengthen the patent position. There are many, many things we did. But one of the things I think most of the biosimilar company really hated, or even just feel like that's a discuss about who developed this kind of strategy and really limited why Humira still be able to stay on the market for 20 years is this. I will just single out one thing, but there are many, many other patents we file. But one of the things is to patent our formulation. And the formulation for any scientist in this audience, and if you don't know what formulation Humira has, and I can tell you, that is a PBS. And it'll be like, you've got to be kidding me. So for anyone not familiar with that, PBS is the most typical buffer you use to keep protein. There's really nothing secret about it. But our team developed a strategy about from the very beginning, thinking about this is so common, but really keep our protein doing very well and simple, right? So then you want to extend that patent life as long as possible. To cut through the chase, the whole patent filing for the formulation, we kind of take advantage about you do have opportunity to do the provision, and then you withdraw, and then you go the provision again and in and out. So basically, Humira's formulation of as simple as the PBS was filed just right before the commercialization. And then even afterward, kind of did quite a bit of tweaking of that. So that limit for any one of you work on Humira biosimilar, you know, like then even you have that your biosimilar Humira got approved, you still need to wait for that patent of the formulation kind of expire a little bit to be able to truly launch your product. That's why, I mean, not until I think the last year, and starting the biosimilar of Humira can be used. And this is probably just one story to share with you about, I think many of the panelists already say the patent strategy itself is important. It's not just the patent itself. So definitely, I think if any wisdom to share is then think about it's not just about the what, but also about the how. So the what is and what is patentable, what is a trade secret, as we all cover, but also how to you file a patent and being smart and things like that have become very important that help your patents alive for a long period of time. And the second perspective about licensing, I'll keep this short because I think we've been on this topic a little bit longer. But definitely, I think I actually want to echo the comment about I don't see just a patent itself, it's more about the whole IP strategy. Even for licensing, that's the same thing. So it can be trade secret, can be the patent, it can be a lot of different combinations, but really it's about the IP position, how strong that is. But if anything, to help any innovator here to think about your strategy, don't overthink about certain things, because usually in academia, what we are filing is about this target and size. Let's just say if you target TNF and you say TNF is a good target for immunological disease, that's good enough from the academia point of view. Of course, you need to file a patent maybe a little bit about your CDR, so then that component is still there. But usually, when you enter industry, we will do the continuing. I think it's being mentioned by others. Continuing doing the filing for the component matters depends on the final version. So I wouldn't overthink about that in the early stage. But later on, when it gets licensing in, the continuing strengthen the position is very important. I'll probably just stop here as a comment about.
I think the messages coming from all of them are very loud and clear that it's not just one-time event, it's part of strategy. And it's easy to say when you think about in our reality here. The academic project team has 2 or 3 years of time or budget to handle this. Okay, they barely got enough money to file the first patent. And then if the tech transfer process takes several years, which is yesterday when I say that, Harvey said, oh Lord, okay. Because in the US, most of university, if they have a good technology, I've done the so-called strategic marketing well, the negotiation time is like 3 months. You got to have tests to go up because any day the technology stay in the academic stage, you're losing the product's lifetime. So here we are, we have to go through a technology transfer. The recipient company has nothing to start with. If you don't have I would say, well, I guess my answer is that should we, even in the early stage, in discovery stage, we encourage people to find professional lawyers who are good at business strategies, patent strategies, to map out and to work with business people. People understand this field, people coming from this disease category, the doctors and the marketing people, but they are not in not in Academia Sinica, okay? But you need those people to put their heads together, working with the patent lawyer, working with the inventor, to put out a blueprint of this patent strategy. And you only may be executing the first part here. But once the product is transferred, they gotta know where did you come from? What's the maximum capability of this patent strategy is gonna deliver? At least that's what the previous people think about. If I was the recipient power, I can add something to it, that's great. If not, at least I should follow what was thought about. I think that probably is a system we need to build in. We never really, at this time, allow that system to do that because product inventions are at the spur of the moment by the brilliant scientists They are spread in all different institutes, different universities. We don't have a sort of like a protocol. But something, again, from today's discussion, maybe we should go back and think about it. Yeah, it's something that other countries may not have the same problem. Taiwan has a very unique situation because our government's so good. They funded all the discoveries. Yeah, but in the future, I'm sure companies like OBI and other companies are getting so strong, and you're doing your own discovery, and you start putting together a strategy and can implement it all the way, right, Dr. Lai? Well, he's nodding. Okay, great. I think we have so much to talk about patent. If we continue to stay on this subject, we'll probably hear like 8 o'clock. Okay. We're going to have to skip some of the important things. Let's move on to project incubations. There are many different ways the investors are. Their lives is not that easy. We always think investors must have such a good life. Every day they sit there and say, well, I like it, I don't like it, okay. They're strong and very stiff competition too. When there's some projects that gone so well, and then later on, they turn out to be doing great things like licensing out and set a record for the total licensing deal. And then if I was one of the investment specialists in one of the investment companies, the boss is going to ask me, why did you turn down that project? Or why didn't you even know the project was raising money? So it is actually very strong. There's strong competition on finding the right project and joining the winning team. Okay, and this is one of this. Today I forgot which talk about distance make a difference. Is we are so far away. We're so far away from where the Boston activities and San Francisco and other places. For all the excellent projects, it's difficult to find a way to get in. Even you have money. Actually, a lot of Taiwanese investors contact Vivo and saying, if you have a good project, please let us know. We'll join you. We can make up the other part of financial requirement. And my boss, which is Frank, will say, what else do you have other than money? And then we say, oh, we have a lot of money. Oh, no, if a good project's there, the last thing they worry about is money. Just like that, oversubscription, okay? So investors nowadays, the hardest thing they're talking about is how do they increase their odds of finding the good project. And once they found it, they can keep control of their shares. They don't let other people come in easily. And how do they manage the success of the growth of the company? I mean, supporting the success. So it's the new thing about investment strategy. But then I think Accelerator, you guys have been doing that, okay? And so I'd like to hear from all your experience. Please feel free to just bring up your own experience. Whatever you have seen, maybe Lauren, you can comment on that, from your interactions with investors. Yeah. There are varieties of strategies they're applying, and what have you seen? Yeah. What are the most, the newest strategies they have?
It's a wonderful question. So, speaking again from the academic perspective, there's a couple newer models we've seen, and the first is that venture capitalists are now sponsoring translational focused research. Oh.
Did you
better?
Yeah, oh yeah.
Sorry. So one of the newer models we've seen in the US, probably starting about 5 years ago, is that venture capitalists are now funding research within the academy. So they are identifying project teams, and they are setting up an infrastructure to start the company. The companies cannot get formed while they're inside the academy, but they're putting all those building blocks together, and they're providing really important mentorship and starting to expose the teams on no-go decisions, how to really evaluate the success and the progress of the technology without emotion. Because as we all know, when it's your technology, you feel very strongly. You love your child. And so they have come and they've set up really, I think, very thoughtful programs to help academic scientists get those frameworks. And so after a period of time, the goal is that a company would then spin out with additional insights behind it. And one of the challenges we see in academia is that companies are spinning out way too early. There's a lot of pressure. The students are graduating, the postdocs are graduating. There's only so much that can happen within the confines of the university. So they leave the nest a little bit too early. Maybe they don't know how to fly quite yet. So I do think it's a really interesting model. We've not sort of seen the full fruits of it yet because they're relatively new. And I don't know, Alice, if you've seen those, but that is a new model that I'm interested in that sort of takes another perspective as compared to a typical accelerator, which is just different.
That's right. Okay.
Yes, and maybe I'll even add the other aspect. Not only are the investors stepping in earlier in the process, and not only VCs, I think a lot of pharma companies, whether it's the corporate VC arm or the pharma BD arm, they also step in a little bit earlier than before to fill in the gap. We also see the universities and research institutions stepping forward a little bit to fill that gap. So a lot of incubation funds, university-based accelerators, etc., that will then also help the development for that extra translational step. So that when we come in from the investor side, we see a more mature technology. Of course, the valuation also reflects that. That's also why the universities are willing to put that forward. And it would be a win-win situation for us as well.
Yeah. I think what Lauren mentioned really touched the thing which I've been very concerned about. It's just for a while, the government has, of course, in Taiwan spent a lot of money through the universities, the academic institutions, doing the basic research, discovering the new drugs. And there are grants, like they give you 4 years of money, and they make you actually, you have to spin off, you have to form a company at the 4th year. From the beginning to that 3 years, and they assume you have something worthwhile, justify to form a company. And so that assumption across the board is very, very dangerous, very risky. And some people rush out too early. And I think without incubation. Now, what incubators are doing, you said they're doing a mentorship. Based on what you observed, what the startup company missed the most? I mean, if they rush out too early, what they missed? What they are lack of?
Well, I guess I'll start by saying, and I agree with Alice, I think especially when universities design their own accelerators, which is just a different model, I think it's really important that these are separate from the tech transfer function. These are professionally staffed with project managers, drug developers. This is no longer an academic exercise. These are competitive programs, and they should be sort of handled as such with deliverables and the like that is not typical in the academic enterprise. But what are people missing? I think it's that whole sense of really layering on. You not only have to understand the science, which is important, but it's especially in drugs, it's the regulatory process. We are having and giving guidance to teams about, do you even know how this is going to get reimbursed? I mean, you should be talking about that very early. You heard from our previous panel about the costs for some of these really innovative drugs. Well, if you build a drug that costs $4 million a dose and no one's going to pay for it, that's not very helpful. So we see a huge value add in adding the regulatory experience, and financing strategy. It's not, as you say, it's not just any money, it's smart money that is deployed strategically to bring the technology to inflection points that then you can raise more money. And so we see a strong benefit for mentors for those aspects that are more on the business and regulatory side.
梁老师 has comment.
Back in the year 2000, when I set up the Technology Transfer Office in 1998, okay, and back in the 2000, we could not find a place for the incubation. Okay, and that's in Taiwan at that time. The most difficult is find a place near to the inventor, so that they can work together. Okay, and so at that time we set up the incubation center at the software park, just near to Nangang Software Park, just near here, and that really helpful. And at that time we rented a place from the Jingjibu, the Economic Administration Office, whatever. Okay, we rented a place from them. We pay about 20 million per year to rent the place. And then we lease them out to our licensee to set up an incubator, to do their incubation company. And we got about less than 10 million. So in other words, we lost about $10 million per year for Academia Sinica, and lasts for 10 years. Okay. But eventually, it worked out very well. Yeah, and the company all become very successful.
Yeah.
So sometimes it really depends on what you need. And at that time, what we need is space near to the Academia Sinica. And actually, because of that success, we have today in here, because we use the software, the incubation center is successful, so we can set up here.
That's right. Well, Judy?
I don't want to be too redundant, but I do think there are three types of incubator type. One is like we talk about from the academic, like here also, set up from the academic institute having the incubator, and I will kind of pull myself back to my prior role as running the entire biotech business for Bayer. We love those things, and definitely this is the university or the academic institute helping to make the idea become much more licensable. So I think that's one type. But definitely there are another two types, very popular also. One is then the invest into certain professors' laboratory. So this for some university, I mean, if I speak for in the US, some university allow that to happen. It seems like MIT does allow, oh no. Yeah, so it's hard. Some of the university allowed and some just don't. I think most of the Boston University don't typically accept that, but certain state university will allow that. But that is actually also very, very helpful. So in a sense, you invest in the laboratory, if you have a particular headcount. So that's another type. And again, I'm just throwing ideas, so maybe certain institute can think about that. And definitely the third type about, so at Bayer we did this, we call arm's length, meaning like you will always keep one arm different distance, not getting there close to kind of dictate them. So we invest in them, the company is still in this incubator stage. We are not owning that company. We arm's length that, so we don't touch the whole management team or things like that, but we try to get really, really close. And this become also pretty popular. So I just want to lay out there are multiple different kinds and definitely different kind of opportunity for any one of you thinking about to present that or maybe building up one. There are different models to consider.
Yeah, I think it's something for the startup teams to think about what they really need. The problem is that if you don't know what you don't know, how do you know where to look for help, right? So it's kind of it's a part of process of growing. That I think not only the project team doesn't have enough to know what they're going to be facing, in front of them. They move into an incubation center. There's tons of incubation centers in Taiwan. Which one can help them? It's really, that's a question. We don't really have enough time. Well, I like what Hong Mingqi 老师说的. We have 100 years to catch up, right? But hopefully we won't have to wait that long. We don't have that depth of the product development knowledge, the advisory capacities here. We have some, but we got too many companies to spread the resources with. So those are the nice problem to have. However, a little bit commercial for our network, the TID group, which is an illegal group because we're not legalized, we're not registered, we're just a network. We have accumulated the knowledge, the expertise from professionals with 20 years plus experience in certain specific areas of expertise. About today, as of today, about almost 400 people in the US and plus Europe. And then they are interacting with 900 people in Taiwan. They are in the new drug, actually in the ecosystem of new drug development. They are interacting together every week. We have weekly seminars. We have functionally based discussion groups, and hopefully virtually we can bring those knowledge partially, through the internet back here. But then of course there are people coming back and start joining the team here, and we need that also a lot more. But anyway, sure, go ahead, please. Yeah.
I think the role an incubator or accelerator play is probably focused on the later stage of the development. Here in Academia Sinica, our office, we ever try to adopt a new model, which is called a venture studio, where investors can participate early in the decision-making process of the research. For example, agenda setting or the formulation of the minimum viable product. But this kind of approach, this concept of bringing investors in the research is quite challenging in Academia Sinica. Because what we think is that our job is basic research, so we shouldn't bring in the commercial influence too early into the academia. So currently we adopt a relatively moderate approach, which is that we encourage our researchers to investigate the landscape, the patent landscape before they are drafting their research proposal, so that they will know what others, especially commercial partners, they have already have the patent portfolios, so that the purpose of align the basic research with the real societal needs can still be fulfilled by this.
That's what also Dr. Liao mentioned earlier. Yeah. I think the competitive landscape through patents search, and also through marketing database search, the clinical.com on in internet, and many things, and then intelligence collection. A lot of those, you go to the conference and you hear this and that, you put the pictures together and you find out who actually are doing the same thing, maybe ahead of you. Okay, so it's really difficult to think that years ago for the scientists to think about they have to be like a detective, okay? But they have to make sure when they put their own inventions out there, that's number one. That's not going to be, threatened by somebody else's. Okay, so it is pushing everybody to be more forward thinking. Okay. I'd like to go back to the patent for one thing I forgot. I think it's important. Lauren said that in the U.S., young students are graduating when they are graduating, they are anxious to get their publications out, not necessarily patent. So they are always under the pressure of trying to file a patent before publication comes out. I said in Taiwan it's for different reasons, where the inventors are trying to get their promotion scored, so they want to push the publication out as fast as possible. But both sides have the same pressure. Is you got to get your patent filed before the things are published, publication went out. What happened? What happened when that dream didn't come true? That you actually were 1 day late. Somehow your patent was filed after publication came out. What kind of remedies there are to take care of that? Is there anything from your official point of view and the official point of view, whatever?
I think in Taiwan, maybe in Taiwan or over the world, most of the researcher in academic or the professor in the university, I think their first priority is to submit the paper submission. However, I think if this research is very valuable, maybe someday it could be the technology transfer, and then some to the commercialize. I think the PI at the same time, you maybe have the concept keep in mind. You can submit your journal paper, and then the same time you file the patent application. However, I think because if you would like to transfer your scientific paper to the patent application, you should have the assistance from the outside, maybe the patent law firm. There's some professional to help you to draft in the application. Maybe it should be some time. If you cannot submit your paper and file your patent application at the same time, I think you can enjoy the grace period when your scientific paper is publication, you can find from the publication day and within 1 year, 12 months, and you file application. I think it's okay. So you should care. Grace period, 12 months.
That's as long as 1 year? In Taiwan?
It's in the U.S.
General 1 year? Okay, that's
other
good to know.
countries are six months.
Mm-hmm.
Yeah.
1 year.
Do you have a lot of these things happen? You see that? How about you? Yeah.
Sadly. But I think there's another aspect to it, which is we do file, something is better than nothing, and we can certainly file within grace periods. But I also like to sit with the inventors and really think about what was in that disclosure. Was it really enabling for the commercial aspects of the invention? And we do some nice prior art searching and planning, and sometimes you can certainly find pieces of the story, as it were, that were not included in the publication that would be valuable for a patent filing. And you're just carving, you're sort of carving around, but it's
the key is to find a real sharp lawyer.
Exactly,
Okay. Good. You have any experience of that?
I would like to add 2 points, because even though we can use grace period as a remedy, but this remedy comes with 2 problems. The first is that not every country recognizes this grace period. Some countries they just don't have this kind of grace period, so you will lose the chance to file patent in that country. And also the length of the period is maybe different. It's not always 1 year. Some only recognize 6 months. And the second problem is that the grace period does not establish priority date. So meaning that it cannot prevent others from publicly disclosing the same technologies. And in that way, they will destroy your patent application. It will make you lose your novelty. So even though there's a remedy, but we don't recommend that.
So you just go ahead, 一头撞墙，懊恼死了。
I would agree. We file immediately. You don't wait till the end of the grace period. You want to protect it, you file as soon as you hear about the disclosure for that reason. And once your paper is published, has been mentioned, then other people start working on it. They're like, oh, what a neat idea. And they start working on different aspects of it in their own lab. So it's really important to act as quickly as possible.
Mm-hmm. Okay, we still have about 9 minutes, okay? I want to bring up a subject which was sensitive for some of us. We were talking business development, which is so-called strategic marketing. I remember I talked to the technology licensing office in Stanford. There was one lady who actually came from Taiwan. Her job, she has a business card. She's a business development person, okay. And then we talked to people in UPenn, and they have the same job and so on. So in Taiwan, who does the business development? When the projects are still in academic institutions, who does that? Is the PI doing that? Or you think the PI should be doing that? Or the tech transfer office doing that?
Well, I have to admit that we currently don't have this kind of expertise in our office. Mm-hmm. So the PI would probably rely mostly on the resources provided by BioTrack.
BioTrack, where's Han Zong?
Yeah, so we encourage those who are interested in having commercialization to seize the resources here in BioTrack.
Why don't you formalize that? Can we formalize that in the BioTrack mission? Have we done that? You don't have an issue because you have nothing to develop business for? I don't, I'm kidding, I'm just joking, yeah. So now you have a good project. We have who goes out and, well, if they are having papers published or presented in a major conference, the inventors, they're themselves going out, right?
Yeah, most of those is done by our inventors.
And that's one of the things they can do, but it's not enough. And you have to systematically put your project on the map of all the big pharma's search team. They're searching good things, and you have to show up in front of them, worldwide, globally. Okay.
I can add one point that what we have done is that we, in terms of exposing our research result to the public, to the commercial world, we periodically will send out our report to those who we think that they may be interested in our technologies. But
publications?
Yes, just like newsletters.
Newsletters. Okay.
And listing new inventions that we think that they may be interested in. Yeah, and also we will participate in something like BioUSA, BioAsia, this kind of event to promote the research results.
Proactively pushing.
Right. But other than that, well, we have very limited resources.
This is better than I first heard when I first came to Taiwan. I asked one of the institutes, I won't mention the name here, I said, how does people know you have a technology that you're ready for licensing? They said, we'll put it on our website. They said, we'll put it out twice a year. I said, who will watch your website, search your website? Oh, 6 months later, found one thing there. And then, so I asked him, I asked them, usually how many people show up at the meetings that you call for people to come in, listen to your presentations? He said, 1 or 2. I said, you spend so much money and so many years and such a great project, and you only got 1 or 2 people listening. And at that time, Taiwan has a practice saying, they have any good subject, project, asset has to be searched. So first, we have to make sure there's no domestic people interested. Then we can tell the world. I say, if no one in Taiwan is interested, what do you think people outside of Taiwan should be interested? So I think that has been changed. That's been now open to everyone. But again, we're we're kind of like a Chinese has a word called 守株待兔. We're holding, staying next to the hole. There's a tree here, and then we want a pretty dumb rabbit comes over and hit the trees and drop in the hole. Okay, and we've been there waiting. I think what we need to do is to become a more active. I know that the U.S. Bio has been used as the one vehicle, but I'm not so sure all those projects we're now are actually ready to talk to people. So I think it's, again, balancing, you know, what's really worthwhile for pushing the project out, and how do you do that? Newsletter definitely could not be ignored, has to be one of the things, yeah. Liang Lao Shi, yeah.
In order to do a business development, actually, one better have some industry experience, and that's very important. But unfortunately, in academia Sinica, most of the people do not have industry experience. And actually, the reason why they hired me back in the 1997 was because I worked at Biogen for a period of time, okay? And I also work at the FDA, so I'm quite familiar with the process. But in most of the people in academia, they do not have that. So in order for them to get the sense of the business development, usually our technology office, our people, try to help them to identify, you know, after we've secured the patent, okay, then try to help them to identify which people can help them.
I think each inventor, each project leader, when they started working on certain things and when they realize that they are actually having a potential drugs coming out, they at that moment should know who should be the one interested in you, right? I think that will be part of the training that we got to make sure that scientists think about the business aspect early enough, yeah. Okay, we have 2 minutes. We're going to open this for everyone, 2 minutes. Come back there, yeah. Someone,
I would like to ask Professor Foster, can you share the MIT experience about how do you find the company for the MIT patents?
Oh, sure. So we do a little bit of all of the above. Our faculty are generally very good promoters of their own research, and they circulate very broadly, not only speaking at scientific conferences, but they consult widely in industry, and they're constantly sort of exposed to business leaders, so they certainly do a piece of it. The Tech Transfer Office collaborates with them, like our colleagues. We do some passive marketing where we post some fairly generic information. We do targeted marketing. We participate in partnering forums at different conferences. Different coverage. It's very interesting that MIT Press and MIT News run stories about different publications that come out, and so it becomes sort of a promotional piece. We are not involved in that. We have a corporate relations arm that, you know, has different activities and sessions that bring together industry, bring them to MIT to engage with our faculty and the licensing office, and we get a fair number of, I'll call it sort of, I call it phishing, and it's not really the bad connotation of phishing, but we might have Takeda come and say, well, you know, we're trying to solve this one particular problem, or we're opening up a new division in X, you know, who at MIT is working on it, what do you have? So I think it's a combination, but I will also add that we are, it's very frequently, as I've shared earlier, that many of our investigators want to do startups. So that is antithetical with marketing to a big company, because they don't want to work with a big company. They don't want to work with an established company. They want us to support them in a startup. So we are sort of playing that balancing act and trying as the owners of the intellectual property to help make that decision. And we work with venture capitalists very routinely, come to us, and we have ongoing relationships about what interesting projects are in your office. So I would say lots of different formal and informal interactions.
From the investment side, I would say the most successful tech transfer, technology development and licensing offices across US are the more proactive ones. They proactively develop relationships with the venture community, the pharma community, the biotech community, so that the first conversation is not an ask. The key thing is that the first conversation with the financier shouldn't be the ask. It should be relationship building, and then the ask can come after. So I would say there is a period of relationship building. I would say biotech and financing, startup creation, venture, these are all very relationship dependent and very relationship driven. And so time needs to be spent in building these relationships so that by the time there are technologies available, it's already conversation 3, conversation 4, and that will drive the technology transfer a lot more smoothly.
This is a tall task, pretty challenging for us to build relationship over internet, right? We have our TID group has probably 20 investor companies in that group, and maybe 18 of them are in Taiwan, but there are a couple from the US, but we need to expand that list. Our current goal is trying to bring in maybe 30 to 40 VCs from the US into our network, because you really have to have that ability to just set up a call and do even if we're not face-to-face, I mean, we're face-to-face through the screen, but at least we have to start feeling comfortable talking, building. And then when you see each other, you feel good. You can share, right? One thing we found out from our TID experience is so interesting. We have so-called 网友, we're internet friends. We built friendship over 3 years and never met each other. But then the first time you met each other, you start hugging each other. And then this should push out and say, actually, we don't even know each other. But that feeling is very interesting. When you're not in the same space, you actually develop a lot of respect, more respect than if you were in the same space for some reason. So I think for those people going through divorce or trying to, the dispute between the husband and wives, I think they should start talking through internet. I'm just joking. There was a question from Datsu.
Okay, actually, I think last year we went to Boston and met Bob Langer, and today we met Harvey Lodish. They both started up many companies. But none of the companies uses the same technology. So I think they are really creative. But here in Taiwan, some people hold the technology like forever and license the first generation to A, and the second generation to B, and then the third generation, and increase the competition. I think that's one of the problems here. And the other thing is I would like to ask Lauren, what's the manpower or relative ratio of your staffs or professionals serving for biotech patent engineering? Because MIT is a university with, just like Tsinghua, we have an engineer school, we have other patents, which may be relatively easier to attract in the industry's eye for a lot of reasons. So what's the manpower? How do you manage that? Thank you.
So first of all, a comment on the two professors you met. It is absolutely true. I handle Bob Langer's portfolio, and it really is a full-time job, and yet I actually have a different job. So it's fairly amazing. But To your specific question about staffing, the licensing team at MIT is split into a life sciences group and a physical sciences and software group, and they are equally staffed. So we have about 25 licensing professionals. They are senior and junior, and we have about 12, 13 on each team.
Okay. 林医师。
Yes, thank you. I think this question is for Lauren. It's kind of like, what's the best practice question? Do you think we should, as TLO, you keep a track of what's going on within the MIT community? Like you do a mapping or landscaping of what kind of research that each of your peers are doing, so that, or you rather passively receive an email from them and then evaluate those projects. Why I'm asking is because I'm now responsible for a company that's doing AI application in healthcare, software as medical device. And when we need solution like fundus camera AI to license in, our general practice is through word of mouth. We pick up a phone and listen to someone like insider and know who is doing this within Taiwan. And it never occurred to me that I would phone a TOO officer from NTU or National Biotechnology University to check what is going on within their campus. It never occurred to me that there's this option. So I don't know whether as a TOO officer, you do a mapping. And so you can serve as a hub of information that when the industry needs something, they can just go straight to you.
So we do have some efforts at that is not typically done through the TLO. So we have a corporate relations function that has a program called the Industrial Liaison Program. And they have a very comprehensive understanding of the areas of expertise and research of the MIT faculty, and their primary goal is to act as stewards for companies that are interested in what is happening at MIT, whether to fund research or do licensing. So they do keep, I'll say, track of that, but you can imagine it's very hard and that information is outdated very quickly. So do we think about that? Absolutely. Do I have peers that I feel welcome to call? Absolutely. But I would still say it's fairly rare that licensing offices, I'll say, bundle technology together on their own accord. It is usually driven by very strong collaborative scientific relationships. So they may say, well, I work with, Bob Langer works with Harvey Lodish. And so they say, well, that's Whitehead and MIT. So I call up Shoji and say, by the way, do you know our people are collaborating? How do we think about this together? It's a very specific passion of mine. I'm really thrilled that you asked that question. I've always thought about, couldn't we be better together? And in providing solutions to industry and not challenging our licensees to go and hunt and peck and get you're nodding, every piece on their own. But if we had complementary pieces that go together, that we could exploit them together. I would say the other situation that's quite common is when trainees leave. So they go to a new institution, they have their own lab. There's often a sort of a strong connection between the tech transfer offices because you have some historical IP at one institution and some of the newer pieces at another. And you get to know people, but I'm sure there's areas for improvement.
Thank you.
If I can add on, because it's for a certain period of time, my current company was seeking for some technology in Taiwan. And definitely, I mean, like when Chong mentioned about Academia Sinica has this inventory. And I don't know if it's common or not common, but the major university, all the technical transfer office all has one. So at least from my experience, so definitely, I mean, if that's something you're looking for, at least in Taiwan, that's a very common practice.
Thank you.
And also, there are two avenues for technology transfer, not just only licensing, but also cooperative research and development agreement. So both are, we all welcome your contact. Yeah, if you are interested in collaborating with the Academia Sinica. Yeah.
Thank you.
Well, are you satisfied with this team?
Yeah, thank you for.
They have experiences. They have answers to your questions. They have ideas how to even improve their own performance in the future. I think we have done a lot this afternoon. And I hope, I think one thing probably is in common that we have, from whatever we talk about here, is that you can't just stay in your cocoon and trying to get everything done. You have to go out. You have to go out, meet people. You have to be nosy about other things. You have to be like, you know the matchmakers. Always, when I see a single girl, a single man, I always say, oh, why don't you make a good pair, right? Something like that. You have to have that eagerness to see things coming together. If you just leave them alone, they probably be always alone. Okay. But anyway, thank you very much for your attention. I hope we had done some job satisfying Wu主任的 request. And how did we do? 及格了没有? Thank you very much. Okay.
So we'd like to thank our moderator and our panelists for this wonderful forum. So now I would like you to remain seated. 好，请帮我继续坐着，我们要拍一张合照，好不好？我们先入座，坐着。好，麻烦一下。对对，请就帮我坐着。So please remain seated and let's take a round of a photo. Okay, look at our photographer in the middle waving his hand. 3, 2, 1. All right, I would like to welcome our introductor to come back to the stage again. 好，我们要再次欢迎引言人到台上来一起合照，欢迎陶执行长。So everybody please rise and then get together, and I would like our introductor to come back to the stage and join you with the photo. 好，今天听了这么精彩的一个趋势论坛，希望大家是收获满满。那也不要忘记明天呢还有精彩的活动，记得一定要再次前来。好，大家靠拢一点 ，Everyone please get closer, get closer 。来，大家一起，好。看一下摄影师 ，Look at photographer. 3, 2, 1. All right. 好，谢谢 ，Thank you so much， 谢谢大家的参与。好，那今天呢，我们所有讲者带来精彩又丰富的分享，相信大家都是收获良多。那我们活动将在这里告一段落了，也提醒各位来宾，等一下呢有这个 Bio Club 的交流会。有受邀的贵宾以及今天的 VIP 跟讲者都欢迎大家可以一起来参加这个 Bio Club 交流会。那它的会场是在3楼，请大家现在就可以开始移动脚步。那也提醒大家，明天的活动将会在8点30哦，早上8点30开放报到。那也提醒大家，就算今天有参与报到过的来宾，明天还是要再次报到哦，因为明天呢，我们报到的时候会发放餐券给各位。这样大家才会有午餐餐盒可以吃，所以请大家要记得明天再次报到索取我们的餐券。那明天的第一个议程会在上午9点钟开始，更多精彩内容请大家一同来感受。We extend our heartfelt thanks to all the speakers for the engaging and insightful presentations, and to all guests for your participation. Today's event is now drawing to a close. For those who invited to Bio Club Banquet, including the session speakers and VIP panelists, you're welcome to go to venue third floor to join Bio Club Banquet. And a reminder that tomorrow's event will open for registration at 8:30 a.m. Remember to register again and collect our lunch coupon. If you join this event today, and you also have to register for tomorrow to receive the lunch coupon. So with the first session starting at 9 a.m., we're looking forward to see you all again tomorrow. See you, bye. 好，同时我们也提醒大家离开的时候不要忘记您的随身物品。再次感谢各位莅临 ，Please remember to bring all your belongings with you. See you all tomorrow. 明天见，拜拜。